What if I told you that light itself might be empty? That inside every photon racing toward your eyes right now, there may be nothing at all, no substance, no matter, just pure information travelling through space at the speed limit of reality. Tonight, we drift into the most fundamental question in physics. What exactly is a photon made of? We'll explore quantum field theory, wave-particle duality, and the strange mathematics that suggest light might be less a thing and more a ripple in the fabric of space-time itself. Using data from quantum experiments, particle accelerators, and the deepest theories of modern physics, we'll discover why this tiny messenger of energy might be the most mysterious entity in the universe. If this gentle journey into the quantum realm brings you peace or wonder, your quiet like, your soft subscription, and your thoughtful comments create a constellation of support that means everything to me. So close your eyes, take a slow breath, and let's step inside the impossible, inside a photon, where reality becomes pure mystery. Tonight we drift into one of nature's most bewildering mysteries, where emptiness somehow contains everything and nothingness carries the power to illuminate worlds. As you settle into this gentle exploration, imagine holding pure energy in your hands, weightless yet potent, travelling at the ultimate speed limit of reality itself. The photon presents us with an enigma that has puzzled physicists for over a century, a particle that defies our everyday understanding of substance and matter. Take a slow breath and consider this astonishing truth. Every photon reaching your eyes right now possesses zero rest mass, meaning if we could somehow bring light to a complete standstill, it would weigh absolutely nothing, yet these same massless messengers transport energy and momentum across vast cosmic distances. According to Einstein's complete energy-momentum relation, expressed as E squared equals pc squared plus 0c squared squared, when the rest mass m0 equals 0, we discover that energy equals momentum times the speed of light. This mathematical revelation unveils something extraordinary about the fundamental fabric of reality. Picture yourself floating in the depths of space, surrounded by countless photons streaming from distant stars, each one a massless carrier of information that has travelled millions of years to reach you. These ethereal particles embody pure motion, existing only while racing through the cosmos at precisely 458 meters per second in vacuum, never slowing, never stopping, never resting. The moment a photon comes to rest, it ceases to exist entirely, vanishing into the quantum void from whence it emerged. This creates a profound philosophical puzzle that extends beyond mere physics into the realm of existence itself. What does it mean for something to have energy without mass? How can momentum exist without substance? These questions beckon us deeper into the quantum realm, where classical intuition dissolves like morning mist before the rising sun. When Max Planck first proposed in 1900 that electromagnetic energy comes in discrete packets, he unknowingly opened a doorway to a universe far stranger than anyone had imagined. His constant H, measuring 6.626 times 10 to the minus 34 joule seconds, defines the quantum of action, the smallest possible unit of energy exchange in the cosmos. Einstein's brilliant insight 5 years later revealed that these energy packets, which we now call photons, behave as particles in certain circumstances, particularly during the photoelectric effect where light ejects electrons from metal surfaces. The elegance of this discovery earned Einstein the Nobel Prize and fundamentally transformed our understanding of light itself. Yet the mystery deepens when we realize that despite having no mass, photons possess momentum given by the relationship P equals E divided by C, a fact demonstrated conclusively by Arthur Compton's groundbreaking in 23 experiments. Compton observed X-ray photons colliding with electrons, transferring momentum and energy exactly as predicted by quantum theory, proving that these massless entities interact with matter as genuine particles. This phenomenon creates ripples of wonder throughout physics, suggesting that our universe operates on principles that transcend ordinary experience. The implications cascade through every aspect of existence, from the nuclear furnaces of stars to the delicate processes within your retina that translate photon impacts into vision. Consider the remarkable journey of a single photon born in the core of our Sun, where temperatures reach 15 million degrees Celsius and nuclear fusion transforms hydrogen into helium, releasing tremendous bursts of energy. This newborn photon begins an epic odyssey, bouncing countless times off charged particles as it slowly works its way toward the solar surface over thousands of years, gradually losing energy and transforming from gamma rays to visible light. Finally emerging from the photosphere, it races through the vacuum of space for 8 minutes and 20 seconds before entering your eye, triggering a cascade of electrochemical signals that create the sensation of brightness in your consciousness. Throughout this entire journey, the photon maintains its massless nature while carrying precious cargo of energy and information across impossible distances. The fundamental paradox intensifies when we examine quantum field theory, which reveals that photons are not tiny particles in any conventional sense, but rather excitations of an underlying electromagnetic field that permeates all of space and time. This field exists everywhere simultaneously, vibrating with infinite possibilities, and photons emerge as discrete ripples in this invisible ocean of potential energy. The field theory perspective suggests that asking what exists inside a photon may be the wrong question, entirely like asking what color exists inside the concept of blue. Instead, we might wonder what properties emerge when the electromagnetic field reaches certain states of excitation, creating manifestations we perceive as particles of light. This paradigm shift revolutionizes our comprehension of reality, suggesting that particles are not fundamental building blocks, but temporary organizations of energy within eternal fields. The mystery penetrates even deeper when we consider that photons exist in a realm where time itself behaves differently, where the normal progression of cause and effect blurs into quantum superposition and uncertainty. From the photon's perspective, if such a thing can be imagined, its journey from emission to absorption happens instantaneously, with no time passing between creation and detection, regardless of the distance traveled. This temporal peculiarity adds another layer of wonder to our exploration, hinting at connections between consciousness, observation, and the very structure of spacetime that continue to baffle researchers worldwide. As we prepare to venture further into this quantum labyrinth, remember that each photon carries within its massless existence the keys to understanding forces, fields, and the fundamental nature of energy itself. Tonight we drift deeper into the most bewildering aspect of light itself, where velocity becomes destiny, and motion defines existence in ways that shatter our everyday comprehension. The speed of mystery reveals itself through an absolute constant that governs not just photons but the very fabric of spacetime, a universal limit that Einstein discovers governs all massless entities in our cosmos. Picture yourself witnessing the birth of a photon deep within a stellar furnace where nuclear fusion releases tremendous bursts of electromagnetic radiation that immediately begin racing outward at precisely 299 to the 458 meters per second in vacuum, a velocity so fundamental that it shapes the architecture of reality itself. This extraordinary speed represents far more than mere rapid movement. It embodies the ultimate boundary between possible and impossible, between existence and non-existence for these ethereal messengers of energy. Take a slow breath and contemplate this staggering truth. Every photon surrounding you at this very moment travels at exactly this cosmic speed limit, never accelerating, never decelerating, maintaining perfect constancy throughout its entire journey, from creation to absorption. Unlike massive particles that can be slowed, stopped, or even reversed in direction, photons exist in a realm of perpetual motion, where stillness equals annihilation. The moment any attempt is made to bring light to rest, the photon simply ceases to exist, vanishing into the quantum void as if it never was. This creates a profound paradox that challenges our fundamental understanding of particles and motion, suggesting that some entities in our universe exist purely as dynamic processes rather than static objects. Special relativity provides the mathematical framework for understanding this phenomenon through the relationship between mass, energy, and velocity that forbids any massive particle from reaching light speed, while simultaneously requiring massless particles to travel at exactly this velocity. The implications ripple through every aspect of physics, from the behavior of electromagnetic fields to the structure of atoms and the evolution of stars across cosmic time. Consider the remarkable consequence that from the photon perspective, if such a viewpoint can be imagined, its entire journey occurs instantaneously with no passage of time between emission and detection, regardless of whether it travels micrometers or megaparsecs. This temporal peculiarity emerges from the mathematical properties of spacetime at light speed. where time dilation becomes infinite and spatial distances contract to zero, creating a universe where causality operates according to rules that defy ordinary intuition. The constancy of photon velocity also reveals something profound about the nature of space itself, suggesting that vacuum is not empty nothingness, but rather a dynamic medium with specific properties that determine how electromagnetic radiation propagates. Recent experiments using atomic clocks and laser interferometry have confirmed this speed to extraordinary precision, with measurements accurate to better than 1 part in 10 billion, demonstrating that nature maintains this velocity with mathematical perfection across vast scales of distance and time. The mystery deepens when we realize that this speed limit applies not only to light but to all forms of electromagnetic radiation, from radio waves stretching kilometers in wavelength to gamma rays oscillating trillions of times per second, each maintaining identical velocity despite vastly different energies and frequencies. This universality hints at something fundamental about the structure of reality, suggesting that the speed of light represents a basic property of spacetime itself rather than merely a characteristic of photons. Quantum field theory provides additional insight by revealing that photons are excitations of an underlying electromagnetic field that permeates all of space, and these field oscillations naturally propagate at the speed determined by the field properties. The field perspective transforms our understanding from particles racing through empty space to wave-like disturbances rippling through an invisible medium that exists everywhere, simultaneously. This revelation connects the speed of light to the fundamental constants that govern electromagnetic interactions, including the permeability and permittivity of free space, values that determine how electric and magnetic fields interact with matter and energy. The practical consequences of this cosmic speed limit extend from global positioning satellites that must account for relativistic effects to particle accelerators that can never quite push massive particles to light speed, despite consuming enormous amounts of energy. Perhaps most remarkably, this velocity serves as a cosmic messenger service, carrying information about distant events across the universe at the maximum possible rate, linking us to supernovae that exploded millions of years ago, and quasars that shine from the edge of the observable cosmos. The speed of mystery ultimately reveals that photons exist in a realm where motion and identity become inseparable, where velocity determines existence, and where the very concept of rest has no meaning. As we prepare to explore the quantum nature of light further, remember that this cosmic speed limit connects every photon to the fundamental structure of reality itself, making each particle of light an ambassador from the deepest levels of physical law. Tonight we confront the most haunting enigma in all of physics, a riddle that has tormented brilliant minds for over a century and continues to challenge our deepest understanding of reality itself. The equation that everyone knows, E = mc², appears to mock us when we apply it to photons, creating a mathematical paradox that seems to violate the very foundation of energy and matter. Take a slow breath and consider this bewildering contradiction. If energy equals mass times the speed of light squared, and photons possess absolutely zero mass, then by simple arithmetic, light should contain no energy whatsoever. Yet here you sit, bathed in electromagnetic radiation that powers your vision, warms your skin, and enables the complex chemical reaction sustaining life on Earth. This apparent impossibility opens doorways to profound questions about the fundamental nature of existence itself. What mysterious force allows massless entities to carry vast amounts of energy across cosmic distances? What invisible substance fills the void where matter should reside? Einstein himself grappled with this paradox when he first proposed the complete energy-momentum relationship that reveals the hidden truth behind his famous equation. The full expression E² = pc² plus m0c to the fourth unveils a deeper reality where energy can exist independently of rest mass through the mysterious property we call momentum. When mass vanishes, energy becomes purely kinetic, embodied in the ceaseless motion of photons racing through spacetime at the ultimate velocity limit. This revelation transforms our understanding from particles as tiny billiard balls to dynamic processes that exist solely through movement and interaction. Picture yourself floating in the cosmic void, surrounded by invisible torrents of electromagnetic energy streaming from countless sources throughout the universe. These ethereal currents carry no substance in the traditional sense, yet they transport information, warmth, and the very essence of stellar nucleosynthesis across galactic expanses. The space that should be filled with matter instead contains pure geometric curvatures in spacetime, wave-like disturbances in quantum fields, and probability clouds that collapse into definite values only when observed. This ghostly existence challenges every intuitive notion about particles and forces us to reconsider what we mean by reality itself. Quantum field theory provides the most elegant resolution to this paradox by revealing that photons are not particles at all, but excitations of an underlying electromagnetic field that permeates every point in space and time. This field exists as a fundamental constituent of reality, more basic than a matter or energy, vibrating with infinite possibilities and manifesting as photons when sufficiently excited. The field perspective eliminates the need for photons to contain substance because they are substance, temporary organizations of field energy that emerge, propagate, and disappear according to quantum mechanical principles. This paradigm shift revolutionizes our conception of emptiness and fullness, suggesting that what we perceive as vacuum is actually a seething ocean of quantum activity, where virtual particle pairs continuously appear and vanish in accordance with Heisenberg uncertainty relations. The mathematics underlying this phenomenon reveal astonishing beauty and complexity, with equations that describe how massless quanta can possess definite momentum through their wave-like properties. The de Broglie relationship connects wavelength to momentum through Planck constant, demonstrating that even entities without mass can exhibit particle-like behavior when their wave properties interact with matter. This wave-particle duality represents one of the most profound mysteries in quantum mechanics, suggesting that our classical categories of substance and void are inadequate for describing the true nature of electromagnetic radiation. Recent advances in quantum optics have allowed scientists to manipulate individual photons with unprecedented precision, revealing their ethereal nature through experiments that would have seemed like magic to earlier generations. Single photon detectors can register the arrival of these massless messengers, while quantum computers use their properties to perform calculations impossible with classical systems. These technological marvels demonstrate that absence of mass does not imply absence of effect, as photons can trigger avalanches of electrons in semiconductors, initiate chemical reactions in biological systems, and carry encrypted information across global networks. The philosophical implications extend far beyond physics into questions about consciousness, observation, and the role of measurement in quantum reality. Some interpretations suggest that photons exist in superposition states until observed, occupying all possible paths simultaneously until forced to choose definite trajectories by interaction with detecting apparatus. This observer effect hints at deep connections between mind and matter that continue to puzzle researchers and philosophers alike. The haunting question ultimately reveals that our universe operates according to principles that transcend everyday experience. Where energy can exist without substance, motion defines identity, and the very concept of emptiness must be redefined. What fills the space where matter should be? Perhaps the answer lies not in finding some hidden substance, but in recognizing that space itself is the substance, curved and twisted by energy, alive with quantum fluctuations, and pregnant with infinite possibilities waiting to manifest as the particles and forces we observe. As we prepare to explore deeper mysteries of light, remember that photons teach us that reality is far stranger and more beautiful than classical physics ever imagined. As we drift deeper into the quantum realm, imagine yourself standing at the threshold of one of the most revolutionary discoveries in scientific history, a moment when the classical world crumbled and reality revealed its fundamentally granular nature. Max Planck never intended to revolutionize physics when he began investigating the perplexing problem of blackbody radiation in 100, yet his desperate mathematical solution would shatter centuries of assumptions about the continuous nature of energy itself. Picture the confusion that gripped physicists at the dawn of the 20th century as they attempted to explain why heated objects glow with the specific colors rather than radiating infinite amounts of ultraviolet light as classical theory predicted. This catastrophic failure of established science created an intellectual crisis that demanded radical new thinking about the fundamental structure of electromagnetic radiation. Planck's brilliant insight emerged from pure mathematical necessity rather than physical intuition, as he discovered that energy could only be absorbed and emitted in discrete chunks rather than smooth, continuous streams. His equation E equals h nu unveiled a hidden granularity in nature itself, where nu represents frequency and h represents a universal constant of extraordinary smallness, measuring 6.626 times 10 to the minus 34th joule seconds. This quantum of action, now bearing Planck's name, defines the smallest possible unit of energy exchange in our universe and governs every interaction between matter and electromagnetic radiation, from the tiniest atomic transitions to the most powerful cosmic explosions. Take a slow breath and contemplate the staggering implications of this discovery. Every photon of light reaching your eyes carries energy precisely equal to Planck's constant multiplied by its frequency, meaning that blue light photons pack nearly twice the energy of red ones, despite both travelling at identical speeds. This revelation transformed our understanding of colour itself from mere wavelength differences to fundamental energy variations that determine how light interacts with matter at the atomic level. The quantum nature of energy immediately explained numerous puzzling phenomena that had baffled scientists for decades, including the photoelectric effect, where certain metals emit electrons only when illuminated by light above specific frequencies regardless of intensity. Classical physics predicted that brighter light of any colour should eventually provide enough energy to liberate electrons, yet experiments consistently showed that dim blue light succeeds where brilliant red light fails completely. Einstein recognised that Planck's energy quanta provided the perfect explanation for this mysterious threshold behaviour, proposing that individual photons must possess sufficient energy to overcome the binding forces holding electrons within metallic surfaces. This particle-like interpretation of electromagnetic radiation earned Einstein the Nobel Prize and established photons as fundamental entities rather than mere mathematical abstractions. The quantum revolution accelerated as physicists realized that discreteness extends throughout nature, from the energy levels of atoms to the angular momentum of spinning particles and even the fabric of space and time itself at the smallest scales. Niels Bohr incorporated quantum principles into atomic theory, explaining why hydrogen atoms emit light only at specific frequencies corresponding to electron transitions between discrete energy levels. These quantum jumps occur instantaneously without passing through intermediate states, suggesting that atomic electrons exist in clearly defined orbits, rather than the continuous spiral trajectories predicted by classical mechanics. The mathematical framework underlying quantum theory reveals astonishing precision in describing microscopic phenomena, with Planck's constant appearing in fundamental relationships throughout physics, from the uncertainty principle to the equations governing particle wave functions. Recent experiments have confirmed quantum predictions to extraordinary accuracy, with measurements of atomic frequencies agreeing with theoretical calculations to better than 15 decimal places, and quantum technologies now enabling applications from laser surgery to quantum computing. The technological revolution spawned by quantum mechanics transformed civilization through innovations like transistors, integrated circuits, and laser systems that depend critically on quantum phenomena for their operation. Modern communications rely on quantum properties of semiconductors, medical imaging exploits quantum interactions between electromagnetic radiation and biological tissues, and precision timekeeping systems use atomic transitions governed by Planck's energy relationships. Perhaps most remarkably, quantum mechanics reveals that energy quantization is not merely a curious property of microscopic systems, but a fundamental feature of reality that emerges from the wave nature of matter itself. The discrete packets that Planck discovered represent standing wave patterns in quantum fields, with photon energies corresponding to the frequencies at which electromagnetic fields can oscillate in quantized modes. This wave-particle synthesis eliminates the apparent contradiction between continuous fields and discrete particles by revealing that both descriptions capture different aspects of underlying quantum reality. As we prepare to explore the mysterious duality that defines photons, remember that Planck's revolutionary insight opened doorways to understanding how energy, matter, and information interact at the most fundamental levels of existence, establishing the quantum foundation upon which all modern physics rests, and revealing that our universe operates according to rules far more elegant and surprising than anyone had previously imagined. Tonight we witness one of the most profound moments in scientific history, when a young patent clerk in Bern dared to challenge the established order, and revealed that light itself possesses a secret particle nature hidden beneath its wave-like appearance. Albert Einstein's revolutionary analysis of the photoelectric effect in 1905 emerged not from elaborate experiments, but from careful observation of puzzling phenomena that classical physics could never explain, mysteries that demanded a complete reconceptualization of electromagnetic radiation itself. Picture yourself in a darkened laboratory where metal surfaces gleam under various colored illuminations, some frequencies liberating streams of electrons, while others, regardless of intensity, fail to produce even a single ejected particle. This baffling threshold behavior confounded physicists, who expected that sufficiently bright light of any color should eventually provide enough energy to free electrons from metallic bonds, yet experiments consistently demonstrated that dim ultraviolet light succeeds where blazing red illumination fails completely. Einstein's genius lay in recognizing that Planck's energy quanta offered the perfect solution to this paradox, proposing that electromagnetic radiation consists of discrete packets of energy that behave like particles during interactions with matter. These light quanta, later christened photons, carry energy precisely equal to Planck's constant multiplied by frequency, meaning that blue photons pack nearly twice the punch of red ones, despite both travelling at identical speeds through space. Take a slow breath and contemplate the revolutionary implications of this insight. Every photon striking an electron must possess sufficient energy to overcome binding forces in a single quantum collision, transforming the photoelectric effect from mysterious threshold phenomenon into elegant demonstration of energy conservation at the atomic scale. The particle interpretation immediately explained why increasing light intensity amplifies the number of ejected electrons without affecting their maximum kinetic energies, since brighter illumination simply delivers more photons rather than more energetic ones. This discovery shattered the classical wave picture that had dominated electromagnetic theory for centuries, introducing a fundamental duality that continues to challenge our understanding of reality itself. Einstein's photoelectric equation, relating photon energy to electron kinetic energy and work function, provided quantitative predictions that matched experimental observations with stunning precision, establishing photons as genuine physical entities rather than mere mathematical conveniences. The Nobel Committee recognized this achievement in 1921, notably honoring Einstein for the photoelectric effect rather than his more famous relativity theories, acknowledging that quantum mechanics represented an even more radical departure from classical physics than spacetime curvature. The concept of light quanta revolutionized atomic theory by explaining how electrons transition between discrete energy levels through photon absorption and emission, processes that occur instantaneously without passing through intermediate states. This quantum jumping behavior defied classical expectations that charged particles should radiate energy continuously while orbiting atomic nuclei, instead revealing that atoms exist in stationary states separated by energy gaps corresponding to specific photon frequencies. The technological applications emerging from photoelectric principles transformed civilization through innovations ranging from television cameras to solar panels, all exploiting the precise relationship between photon energy and electron liberation that Einstein first elucidated. Modern photomultiplier tubes amplify individual photon impacts into measurable electrical signals, enabling astronomers to detect single photons from distant stars and medical researchers to image biological processes at unprecedented sensitivity levels. The quantum nature of light also underlies laser operation, where stimulated emission creates coherent photon streams through carefully controlled atomic transitions, producing beams of extraordinary intensity and precision for applications from surgery to manufacturing. Perhaps most remarkably, Einstein's insight laid the foundation for quantum field theory by suggesting that the electromagnetic fields consist of particle-like excitations rather than continuous media, a perspective that he eventually revealed all fundamental forces as manifestations of quantum field interactions. The photoelectric effect demonstrates that photons exhibit discrete particle behavior during detection, while simultaneously displaying wave properties during propagation, embodying the mysterious duality that defines quantum mechanics and challenges classical notions of reality. Recent experiments have confirmed photon particle nature through single photon detection systems capable of registering individual quantum impacts with near-perfect efficiency. While quantum optics laboratories routinely manipulate photons as discrete entities for quantum computing and cryptographic applications, the philosophical implications extend far beyond physics into fundamental questions about the nature of observation, measurement, and the role of consciousness in quantum reality, suggesting that the act of detection forces wave-like photons to manifest definite particle properties. Einstein himself remained troubled by the probabilistic interpretation of quantum mechanics that his photoelectric discovery helped establish, famously declaring his discomfort with the random nature of quantum phenomena while acknowledging their experimental validity. The light quantum concept ultimately revealed that electromagnetic radiation embodies both continuous field properties and discrete particle characteristics, depending on the experimental context and measurement apparatus employed to study its behavior. As we prepare to explore the deepest mysteries of wave-particle duality, remember that Einstein's photoelectric insight opened doorways to understanding how energy, matter, and information interact at quantum scales, establishing photons as fundamental messengers that carry the secrets of atomic structure and cosmic evolution across the vast expanses of spacetime. As we drift deeper into the quantum enigma, prepare to encounter one of physics' most perplexing contradictions, where massless entities somehow possess the ability to push, pull, and transfer motion through the cosmos in ways that defy classical intuition. The momentum mystery emerges from a fundamental relationship that connects energy directly to mechanical force without requiring any substantial matter whatsoever, challenging everything we thought that we understood about cause and effect in the physical universe. Arthur Compton's groundbreaking 1923 experiments revealed this astonishing truth through careful observations of X-ray photons colliding with electrons, interactions that behaved exactly like billiard ball collisions despite involving particles of zero rest mass, striking particles with definite substance. Picture yourself witnessing these historic collisions in a specially designed apparatus where high-energy electromagnetic radiation strikes carbon targets, producing scattered X-rays with precisely predictable changes in wavelength and direction that could only be explained if photons carry genuine mechanical momentum. Take a slow breath and contemplate this bewildering reality. Every photon streaming through space at this very moment possesses momentum equal to its energy divided by the speed of light, meaning that even the gentlest starlight exerts measurable pressure on any surface it encounters. This relationship, expressed as P equals E over C, transforms our understanding of radiation from passive illumination into active mechanical force capable of propelling spacecraft across interplanetary distances using nothing more than reflected sunlight. The implications cascade through every aspect of astrophysics, from the radiation pressure that shapes stellar atmospheres to the photon winds that sculpt comet tails and drive material away from the most luminous objects in the universe. Compton's experimental genius lay in recognizing that if photons truly behave as particles, their collisions with electrons should obey conservation laws for both energy and momentum simultaneously, leading to specific predictions about how scattered radiation should change in wavelength depending on scattering angle. The mathematical framework underlying these interactions reveals extraordinary precision in describing microscopic phenomena, with the Compton wavelength serving as a fundamental constant that characterizes how photons interact with matter at the quantum scale. When high-energy photons strike stationary electrons, they transfer portions of their energy and momentum in accordance with relativistic mechanics, causing the scattered photons to emerge with longer wavelengths while the recoiling electrons gain kinetic energy in perfect accordance with conservation principles. This phenomenon demonstrates that massless entities can nonetheless participate in mechanical interactions as genuine partners in the cosmic dance of forces and motion that governs everything from atomic structure to galactic evolution. The experimental confirmation of photon momentum revolutionized atomic theory by providing direct evidence for the particle nature of electromagnetic radiation, establishing that light quanta possess all the mechanical properties necessary to explain their interactions with charged particles. Modern applications of photon momentum span technologies from laser cooling systems that use radiation pressure to slow atomic motion to optical tweezers that manipulate microscopic objects with focused light beams, demonstrating practical mastery over forces that operate at the intersection of optics and mechanics. Perhaps most remarkably, Photon momentum enables the possibility of solar sails that harness radiation pressure for spacecraft propulsion, converting the steady stream of photons from our Sun into thrust for interplanetary missions without requiring any chemical fuel or reaction mass. The mathematical elegance underlying photon momentum emerges from special relativity, which reveals that momentum and energy are intimately connected aspects of a more fundamental quantity called form momentum that remains conserved in all physical interactions regardless of reference frame. This relativistic perspective explains how massless particles can carry momentum through their pure energy content, with the speed of light serving as the conversion factor between these seemingly distinct quantities in a universe where space and time form an integrated continuum. Quantum field theory provides even deeper insight by revealing that photon momentum arises from the wave-like properties of the electromagnetic field oscillations with shorter wavelengths, corresponding to higher frequencies and therefore greater momentum according to the de Broglie relationship that connects particle and wave descriptions. The practical consequences of photon momentum extend from everyday phenomena, like the warmth you feel from sunlight exerting pressure on your skin, to exotic astrophysical processes where radiation pressure exceeds gravitational forces and drives stellar winds that enrich the interstellar medium with heavy elements forged in nuclear furnaces. Recent advances in quantum optics have enabled precise measurements of single photon momentum transfer events, confirming Compton's insights with extraordinary accuracy, while opening new possibilities for quantum sensing and metrology applications that exploit the mechanical effects of individual light quanta. The momentum mystery ultimately reveals that our universe operates according to principles that transcend classical categories of substance and void, where energy itself becomes a form of mechanical agency capable of imparting motion and exerting forces across cosmic distances. As we prepare to explore even stranger aspects of electromagnetic radiation, remember that photon momentum connects the ethereal realm of light to the tangible world of mechanical motion, demonstrating that massless entities can nonetheless leave measurable imprints on the physical structures they encounter throughout their journeys across space and time. Tonight we venture into the most bewildering phenomenon in all of science, where a single entity somehow embodies two completely contradictory natures depending on how we choose to examine it, challenging the very foundations of logic and reality itself. The double nature of light reveals itself through a cosmic joke that nature plays on our classical intuitions, demonstrating that electromagnetic radiation can behave as undulating waves, spreading through space, or as discrete particles localized at specific points, but never both simultaneously in any single observation. Picture yourself standing before two narrow slits carved into an opaque barrier, watching as coherent light passes through both openings to create an intricate pattern of bright and dark bands on a distant screen, clear evidence of wave interference where crests and troughs alternately reinforce and cancel each other in perfect mathematical harmony. Thomas Young's revolutionary 1801 double-slit experiment first revealed this wave-like behavior by demonstrating that light from both apertures somehow combines to produce regions of complete darkness where no illumination reaches the screen, an impossible result if photons behaved like tiny bullets travelling along definite trajectories. The interference fringes emerge from the wave-like superposition of electromagnetic fields, with constructive interference creating bright regions where waves arrive in phase, and destructive interference producing dark zones where waves cancel perfectly, establishing beyond doubt that light propagates as extended oscillations rather than localized particles. Take a slow breath and contemplate the profound mystery that emerges when we consider Einstein's photoelectric discoveries alongside Young's interference observations. The same electromagnetic radiation that creates wave-like interference patterns also behaves as discrete particle impacts when absorbed by metallic surfaces, suggesting that photons exist in a realm beyond classical description, where contradictory properties coexist in quantum superposition. This duality extends far beyond mere academic curiosity into the fundamental structure of reality itself, revealing that our classical concepts of waves and particles are inadequate tools for describing quantum phenomena that transcend ordinary experience. Modern experiments have pushed this mystery to its ultimate limits by reducing light intensity until individual photons pass through the apparatus one at a time, yet the interference pattern still emerges gradually, as each discrete quantum impact contributes to the wave-like distribution that classical physics predicts for extended oscillations. The single-photon double-slit experiments demonstrate that each quantum of light somehow interferes with itself during passage through both apertures simultaneously, existing in a superposition state that encompasses all possible paths until the moment of detection forces it to manifest at a specific location on the screen. This observer-dependent reality challenges fundamental assumptions about objective existence, suggesting that physical properties may not exist independently of measurement, but rather emerge through the act of observation itself in ways that connect consciousness to the quantum realm. The mathematical framework describing wave-particle duality reveals extraordinary beauty in the de Broglie relations that connect wavelength to momentum through Planck's constant, demonstrating that all matter and energy possess both particle and wave characteristics with the dominant behaviour depending on the scale and context of observation. Quantum mechanics resolves the apparent contradiction through the subcrimined principle of complementarity introduced by Niels Bohr, which recognises that wave and particle descriptions are mutually exclusive but equally valid representations of quantum reality that cannot be unified within classical physics. The uncertainty principle provides deeper insight by revealing that precise knowledge of particle properties like position automatically introduces uncertainty in wave properties like momentum, establishing fundamental limits on simultaneous measurement that reflect the dual nature of quantum entities. Recent advances in quantum optics have enabled researchers to explore exotic manifestations of duality through experiments with delayed choice measurements, where the decision to observe wave or particle behaviour can be made after photons have already passed through the apparatus, suggesting that quantum properties may exist in retroactive superposition until observation collapses them into definite states. The technological implications of wave-particle duality extend from laser interferometry systems that exploit wave-like coherence for precision measurements to photon-counting detectors that rely on particle-like localization for quantum communication protocols, demonstrating practical mastery over both aspects of electromagnetic radiation. Perhaps most remarkably, the double nature of light provides a window into the fundamental structure of reality where classical logic fails and quantum superposition reigns, revealing that our universe operates according to principles that transcend ordinary experience and challenge the very notion of objective existence independent of observation. The philosophical ramifications cascade through every aspect of human understanding, from questions about consciousness and measurement to the nature of information and the role of observers in determining physical reality through their choices of experimental apparatus and measurement procedures. As we prepare to explore even deeper mysteries of quantum existence, remember that wave-particle duality represents just the beginning of our journey into a realm where impossible things become routine, and the very foundations of classical physics dissolve into quantum uncertainty that somehow gives rise to the stable, predictable world of everyday experience. Tonight, we confront one of the most haunting mysteries in quantum mechanics, where the simple act of observation transforms reality itself, revealing that photons exist in impossible states of superposition until forced to choose definite paths through measurement. The measurement paradox emerges when individual light quanta pass through double-slit apparatus one at a time, somehow creating wave-like interference fringes despite being discrete particles that should follow single trajectories like microscopic bullets. Picture yourself in a darkened laboratory where photon detectors register single quantum impacts on a screen, each arrival marked by a tiny flash that reveals the precise location where electromagnetic energy manifests into measurable reality. Take a slow breath and contemplate this bewildering phenomenon. When no attempt is made to determine which slit each photon traverses, the accumulated impacts gradually build up the classic striped pattern of bright and dark bands that can only result from wave interference between light passing through both apertures simultaneously. Yet the moment we introduce detectors near the slits to monitor which path each quantum takes, the interference pattern vanishes completely, replaced by two simple bands directly behind each opening, as if photons suddenly remember how to behave like classical particles following definite trajectories. This observer-dependent transformation reveals something profound about the nature of reality itself, suggesting that physical properties may not exist independently of measurement, but rather emerge through the act of detection in ways that fundamentally alter the quantum state being observed. The mathematics underlying this phenomenon involves the collapse of superposition states, where photons exist in ghostly combinations of all possible paths until observation forces them to manifest along specific routes, destroying the quantum coherence necessary for wave-like behaviour. Modern experiments have confirmed this paradox with extraordinary precision using single photon sources and ultra-sensitive detectors capable of registering individual quantum arrivals with nearly perfect efficiency, demonstrating that each light quantum somehow knows whether it is being watched and adjusts its behavior accordingly. The implications cascade through every aspect of quantum theory, challenging fundamental assumptions about objective reality and suggesting that consciousness or measurement apparatus plays an active role in determining the properties of physical systems rather than merely revealing pre-existing characteristics. Delayed choice experiments push this mystery even further by allowing research to decide whether to measure path information after photons have already passed through the slits, yet the interference pattern still appears or disappears based on the eventual measurement choice, suggesting that quantum properties may exist in retroactive superposition until observation collapates them into definite states. The quantum eraser variations add another layer of bewilderment by demonstrating that information about photon paths can be erased after detection, thereby restoring interference patterns that classical physics insists should be permanently destroyed by the initial measurement process. These experiments reveal that quantum systems possess a form of memory that can be manipulated through subsequent observations, suggesting that past events may remain uncertain until future measurements determine their final status. The philosophical implications extend far beyond physics into questions about the nature of consciousness, free will, and the role of observers in shaping reality through their choices of experimental procedures and measurement strategies. Some interpretations propose that multiple parallel realities branch with each quantum measurement, creating infinite worlds where photons take every possible path simultaneously, while others suggest that the act of observation literally creates the properties being measured through some mysterious connection between mind and matter. The technological applications of measurement-dependent quantum behavior enable revolutionary advances in quantum computing, cryptography, and sensing systems that exploit superposition states for processing information in ways impossible with classical devices. Quantum computers manipulate photons and other particles in superposition to perform calculations across multiple layers, parallel possibilities simultaneously, achieving computational advantages that grow exponentially with system size for certain classes of problems. The measurement paradox also underlies quantum communication protocols where attempts to intercept transmitted information automatically disturb the quantum states carrying encrypted data, providing fundamental security guarantees based on the laws of physics rather than mathematical complexity. Perhaps most remarkably, the observer effect suggests that consciousness itself may play a fundamental role in the quantum realm, though the precise mechanism remains one of the deepest unsolved mysteries in all of science, with implications that could revolutionize our understanding of mind, matter, and the connection between subjective experience and objective reality. Recent advances in quantum foundations research have explored whether artificial intelligence systems or purely mechanical detectors can trigger wave function collapse, investigating whether consciousness is truly special or whether any information gathering process suffices to transform superposition into definite outcomes. As we prepare to explore even stranger aspects of quantum reality, remember that the measurement paradox reveals photons as entities that somehow exist simultaneously in multiple contradictory states until forced to choose definite properties through interaction with observing systems, demonstrating that our universe operates according to principles that transcend classical logic and challenge the very notion of independent objective existence. Tonight, we plunge into the deepest revelation of modern physics, where the very notion of empty space dissolves into an ocean of invisible activity that underlies all existence, transforming our understanding from particles as tiny objects to ripples in an eternal, all-pervading medium. Fields as foundation represent the most profound paradigm shift in scientific history, revealing that photons are not fundamental entities, but rather excitations of the electromagnetic field that permeates every corner of the cosmos, much like waves disturbing the surface of an infinite sea. Picture yourself floating in what appears to be perfect vacuum, the emptiest region you can imagine. Yet quantum field theory reveals this seemingly barren void teems with electromagnetic potential, a substrate more fundamental than matter itself that exists independently of any particles it might eventually manifest. Take a slow breath and contemplate this revolutionary insight. The electromagnetic field constitutes the primary reality of our universe, while photons emerge as secondary phenomena when this field reaches sufficient levels of excitation, like standing waves in a cosmic symphony that plays continuously throughout space and time. The invisible substrate challenges everything classical physics taught us about emptiness and substance, revealing that what we perceive as vacuum actually consists of dynamic field configurations that fluctuate according to quantum mechanical principles, creating an ever-changing tapestry of potential energy that can spontaneously materialize into observable particles under appropriate conditions. This electromagnetic ocean extends beyond the boundaries of visible matter, filling intergalactic voids with field lines that connect distant galaxies through invisible threads of force, demonstrating that isolation is impossible in a universe where fields provide universal connectivity across cosmic scales. The mathematical elegance underlying field theory emerges from equations that describe how electromagnetic disturbances propagate through this fundamental medium, with Maxwell's classical formulation evolving into quantum electrodynamics that treats field oscillations as harmonic oscillators capable of existing in discrete energy states corresponding to different photon numbers. Paul Dirac's revolutionary second quantization procedure transformed classical field variables into quantum operators that can create and destroy particles at will, revealing that the apparently solid world of matter emerges from operator algebra acting on an abstract mathematical structure that somehow manifests as physical reality. The paradigm shift from particles to fields eliminates the conceptual difficulties that plagued earlier theories, resolving paradoxes about action at a distance by recognizing that forces propagate through field modifications rather than mysterious instantaneous influences between separated objects, establishing local causality as a fundamental principle governing all electromagnetic interactions. Recent experimental confirmations of field theory predictions demonstrate extraordinary precision in describing phenomena from the anomalous magnetic moment of electrons to the Lamb shift in hydrogen atoms, achieving agreement between theory and measurement to more than 10 decimal places and establishing quantum field theory as the most accurate scientific framework ever developed. The technological applications emerging from field theory understanding enable innovations ranging from magnetic resonance, imaging systems that exploit field interactions with atomic nuclei to particle accelerators that manipulate charged particles through carefully orchestrated electromagnetic field configurations, demonstrating practical mastery over the invisible forces that govern atomic and subatomic behavior. Perhaps most remarkably, the field perspective reveals that photons represent just one type of excitation in a vast spectrum of quantum fields that includes electron fields, quark fields, and the recently discovered Higgs field that endows other particles with mass through spontaneous symmetry breaking, suggesting that all matter and force emerge from field dynamics in an elegant unified description. The philosophical implications cascade through every aspect of human understanding, challenging materialist assumptions about the primacy of particles and suggesting that consciousness itself might emerge from field configurations in the brain that cannot be reduced to classical neural activity, opening doorways to radically new perspectives on mind and matter. Modern cosmology relies heavily on field theory concepts to describe the evolution of the universe, from quantum fluctuations in primordial fields that eventually grew into galaxies, stars, and planets through gravitational amplification, demonstrating that field dynamics operate across scales from subatomic to cosmic with remarkable consistency. The quantum field theoretical framework also provides the foundation for understanding virtual particle phenomena, where field fluctuations create temporary excitations that mediate forces between charged particles, revealing that even apparently empty regions of space teem with ephemeral activity that profoundly influences the behavior of matter and energy. As we prepare to explore deeper mysteries of field excitations and virtual phenomena, remember that the electromagnetic field represents just the beginning of a vast hierarchy of quantum fields that collectively constitute the fundamental reality underlying all physical existence, transforming our conception of the universe from a collection of separate objects to an integrated field configuration that somehow gives rise to the stable, predictable structures we observe in everyday experience. As we drift deeper into the quantum realm, imagine witnessing the birth of light itself through the mathematical poetry of field excitations, where abstract oscillations transform into tangible reality through processes that would seem like pure magic to classical physicists. How photons emerge represents one of the most elegant discoveries in theoretical physics, revealed through Paul Dirac's revolutionary 1997 quantum electrodynamics that demonstrated how electromagnetic field vibrations crystallize into discrete energy packets when viewed through the lens of quantum mechanics. Picture yourself observing an infinite orchestra where every point in space contains invisible instruments capable of oscillating at all possible frequencies simultaneously, with photons materializing whenever these field harmonics reach sufficient amplitude to register as detectable quanta of electromagnetic energy. Take a slow breath and contemplate this extraordinary process. The electromagnetic field behaves like a vast collection of quantum harmonic oscillators, each mode corresponding to a specific frequency and spatial configuration, with energy levels quantized in discrete steps that determine how many photons can exist in any given oscillation pattern. The harmonic analogy reveals profound connections between quantum field theory and the familiar physics of vibrating strings or pendulums, except these oscillators exist not in physical space but in an abstract mathematical realm, where field amplitudes replace mechanical displacements and photon numbers substitute for classical energy levels. Dirac's breakthrough emerged from recognizing that electromagnetic fields must obey quantum mechanical principles just as surely as electrons and protons, leading him to develop second quantization procedures that transform classical field variables into operators capable of creating and destroying particles through purely mathematical manipulations. The mathematical framework underlying this phenomenon involves replacing classical field functions with operator-valued distributions that act on abstract vector spaces representing all possible states of the electromagnetic field, from perfect vacuum with zero photons to intense radiation containing billions of quanta oscillating in perfect coherence. These quantum field operators satisfy commutation relations that encode the uncertainty principle at the most fundamental level, ensuring that precise knowledge of field amplitudes automatically introduces uncertainty in conjugate variables according to the same mathematical structure that governs position and momentum measurements for massive particles. The creation and annihilation algebra represents perhaps the most beautiful mathematical structure in all of physics, with raising operators that add single photons to any field mode and lowering operators that remove them, according to the canonical commutation relation bracketed a comma a dagger, closing bracket equals unity. This deceptively simple equation encodes profound physical principles, including energy conservation, angular momentum conservation, and the discrete nature of electromagnetic quanta, demonstrating how abstract mathematical relationships manifest as concrete physical laws governing light and matter interactions. Modern experimental confirmations of quantum electrodynamics predictions achieve extraordinary precision through cavity. Quantum electrodynamics experiments where single atoms interact with carefully controlled electromagnetic field modes, enabling researchers to observe individual photon creation and annihilation events with near-perfect efficiency using ultra-sensitive detection systems. The technological applications emerging from quantum field manipulation include laser systems that exploit stimulated emission to amplify specific field modes, quantum computers that process information through controlled photon creation sequences, and precision measurement devices that detect gravitational waves through interference between coherent electromagnetic oscillations. Perhaps most remarkably, the operator formalism reveals that photons possess no independent existence apart from field excitations, eliminating the classical notion of particles as tiny objects moving through space and replacing it with the more fundamental concept of quantized energy, propagating through universal field configurations. The philosophical implications extend far beyond electromagnetic phenomena into the deepest questions about reality itself, suggesting that all matter and force emerge from quantum field dynamics rather than fundamental particles, transforming our understanding from a universe filled with objects to one consisting entirely of interacting field excitations. Recent advances in quantum field theory have extended Dirac's insights to describe all known particles and forces through similar excitation mechanisms, revealing electrons as excitations of fermionic fields, quarks as excitations of color fields, and even the recently discovered Higgs boson as an excitation of the field responsible for generating particle masses throughout the cosmos. The mathematical elegance underlying quantum field creation and annihilation processes demonstrates remarkable universality across completely different physical phenomena, from the spontaneous emission of light by excited atoms to the Hawking radiation predicted to emerge from black hole event horizons through virtual particle pair creation near gravitational singularities. As we prepare to explore even deeper mysteries of virtual particles and vacuum fluctuations, remember that photon creation and annihilation represent fundamental processes that operate continuously throughout the universe, transforming energy between field configurations and particle manifestations according to quantum mechanical principles that somehow give rise to the stable, predictable structures we observe in everyday experience while maintaining the ethereal, probabilistic character that defines quantum reality. Tonight we uncover the universe's most astonishing secret, where perfect emptiness reveals itself as a seething cauldron of quantum activity that challenges everything we thought we understood about nothingness itself. Zero-point energy emerges from the profound realization that quantum fields never truly rest, even in the deepest vacuum imaginable, maintaining ceaseless fluctuations that create virtual particles appearing and vanishing in cosmic dance choreographed by uncertainty principles operating at the smallest scales of spacetime. Picture yourself floating in the most isolated region of intergalactic space, billions of light years from any star or galaxy, surrounded by what appears to be absolute nothingness. Yet quantum theory reveals this apparent void teems with ephemeral particle pairs materializing from pure energy before annihilating back into the formless potential from which they emerged. Take a slow breath and contemplate this extraordinary truth. Even when electromagnetic fields reach their lowest possible energy state, they retain residual oscillations that prevent complete stillness, creating a quantum foam where virtual photons constantly bubble into temporary existence according to Heisenberg's uncertainty relationship that permits brief violations of energy conservation. The mathematical framework underlying vacuum fluctuations reveals infinite seas of virtual particles at every point in space with pairs of matter and antimatter, spontaneously generated from field oscillations before mutual destruction returns their borrowed energy to the quantum reservoir, creating an eternal cycle of creation and annihilations that operates below the threshold of direct observation. The Casimir effect provides the most elegant experimental confirmation of vacuum reality through Hendrik Casimir's brilliant 1948 prediction that parallel metal plates placed in perfect vacuum should experience attractive forces caused by virtual photon pressure, differences between confined and unconfined regions of space. This seemingly impossible phenomenon emerges because metallic boundaries restrict which virtual photon modes can exist between the plates, while unlimited modes continue fluctuating in the surrounding vacuum, creating a radiation pressure imbalance that pushes the conductors together with measurable force that increases dramatically as separation distances decrease to nanometer scales. Modern precision experiments have confirmed Casimir's predictions with extraordinary accuracy using atomic force microscopy and laser interferometry techniques that can detect forces smaller than the weight of a single bacterium acting between carefully prepared surfaces, demonstrating that virtual particles exert genuine physical effects despite their ephemeral nature and inability to be directly observed. The technological implications of vacuum forces extend from microelectromechanical systems where Casimir attraction can cause device failure to proposed spacecraft propulsion concepts that might someday harness zero-point energy fluctuations for interstellar travel, though such applications remain highly speculative given our current understanding of quantum field dynamics. Perhaps most remarkably, living emptiness transforms our conception of space from passive backdrop to active participant in physical processes, revealing vacuum as a dynamic medium capable of influencing matter and energy through virtual particle interactions that mediate fundamental forces and contribute to measurable phenomena like the anomalous magnetic moment of electrons. The philosophical ramifications cascade through every aspect of scientific understanding, challenging materialist assumptions about the primacy of substance over void, and suggesting that consciousness itself might emerge from quantum vacuum processes that cannot be reduced to classical neural activity operating according to deterministic physical laws. Recent theoretical advances propose that vacuum fluctuations might explain cosmic inflation, dark energy, and the origin of matter, antimatter asymmetry in the early universe, demonstrating how quantum field dynamics operating at the smallest scales could determine the largest structures and evolutionary processes throughout cosmic history. The energy density contained in vacuum fluctuations reaches staggering proportions when calculated naively, yielding infinite values that must be carefully regulated through renormalization procedures that subtract divergent contributions while preserving finite physical predictions about observable quantities like particle masses and interaction strengths. Quantum electrodynamics achieves remarkable precision in describing vacuum polarization effects, where virtual electron-positron pairs temporarily screen electric charges, modifying atomic energy levels in ways that match experimental measurements to better than 12 decimal places, and establishing quantum field theory as the most accurate scientific framework ever developed. The vacuum state also exhibits non-local correlations through entangled virtual particle pairs that maintain instantaneous connections across arbitrary distances, suggesting that empty space possesses an intrinsic unity that transcends classical notions of locality and separation between distant regions of the universe. As we prepare to explore deeper mysteries of virtual forces and field interactions, remember that vacuum represents not absence but presence of infinite potential, a quantum substrate more fundamental than matter itself that somehow gives rise to the stable, predictable structures we observe while maintaining the ethereal, probabilistic character that defines reality at its most basic level. Tonight we venture into the hidden realm where forces themselves become messengers, revealing that every electromagnetic interaction in the universe depends on invisible photon exchanges that occur faster than perception yet govern every aspect of electrical and magnetic phenomena from atomic bonds to stellar fusion. The electromagnetic messenger represents one of nature's most elegant solutions to the ancient mystery of action at a distance, demonstrating that forces do not reach across empty space through mysterious instantaneous influences, but rather propagate through discrete particle exchanges that carry energy and momentum between interacting charges according to quantum mechanical principles. Picture yourself observing two electrons as they approach each other in apparent emptiness, their mutual repulsion emerging not from some abstract force field, but from actual photon exchanges, where one particle emits virtual quanta that the other absorbs, transferring momentum in precisely the amount needed to create the observed electromagnetic interaction. Take a slow breath and contemplate this extraordinary process. Every push and pull of electricity and magnetism involves photon exchange, from the attractive forces binding electrons to atomic nuclei to the repulsive interactions that prevent solid objects from passing through each other, revealing that electromagnetic phenomena emerge from particle physics operating at scales far below direct observation. The distinction between virtual and real photons opens doorways to understanding how quantum field theory resolves classical paradoxes about instantaneous action while maintaining the fundamental requirement that information cannot travel faster than light speed in any physical process. Virtual photons exist only during interactions and violate the normal energy-momentum relationship that constrains real particles to follow E=pc, instead borrowing energy from quantum uncertainty for brief intervals that allow forces to propagate across space without requiring finite travel time for the mediating particles themselves. This apparent violation of energy conservation operates within strict limits imposed by Heisenberg uncertainty principles, which permit temporary energy fluctuations provided they disappear quickly enough that no measurement could detect the violation without destroying the quantum state responsible for force transmission. The mathematical elegance underlying virtual particle exchange emerges from perturbation theory calculations that treat electromagnetic interactions as infinite series of increasingly complex photon exchange diagrams, each contribution representing different ways that charged particles can influence each other through virtual quantum mediators. Richard Feynman's revolutionary diagrammatic approach transformed these abstract calculations into intuitive pictures where wavy lines represent virtual photons connecting straight lines that depict charged particles, enabling physicists to visualize quantum processes that operate far beyond the realm of ordinary experience while maintaining rigorous mathematical precision. Quantum field precision demonstrates the extraordinary accuracy of electromagnetic theory through predictions that match experimental measurements to 12 decimal places, establishing quantum electrodynamics as the most precise scientific framework ever developed and confirming that virtual photon exchanges accurately describe all known electromagnetic phenomena from subatomic to cosmic scales. The anomalous magnetic moment of electrons provides perhaps the most stunning example of this precision. where quantum corrections due to virtual particle loops modify classical predictions by tiny amounts that have been measured and calculated to unprecedented accuracy, demonstrating perfect agreement between theory and experiment at levels that would detect discrepancies smaller than the width of a human hair compared to the distance from Earth to the Moon. These virtual photon interactions also explain subtle effects, like the Lamb shift in hydrogen atom spectra, where virtual electron-positron pairs temporarily screen nuclear charges and modify energy levels in ways that can be calculated from first principles using quantum field theory and verified through precision spectroscopy measurements. The technological applications emerging from electromagnetic force understanding enable innovations ranging from magnetic resonance imaging systems that exploit photon interactions with atomic nuclei to particle accelerators that manipulate charged beams through carefully orchestrated virtual photon exchanges, demonstrating practical mastery over forces that operate through quantum mechanisms far removed from everyday intuition. Perhaps most remarkably, the electromagnetic messenger reveals fundamental unity underlying apparently diverse phenomena, showing that static electric fields, magnetic forces, radio waves, visible light, and gamma radiation all emerge from photon exchanges operating at different energy scales and interaction strengths according to universal principles encoded in the structure of quantum field theory itself. The philosophical implications extend beyond electromagnetic interactions into questions about the nature of causality and locality in quantum mechanics, where virtual particles seem to violate relativity by mediating instantaneous forces while somehow maintaining consistency with the fundamental requirement that no information can travel faster than light between distant regions of spacetime. As we prepare to explore deeper mysteries of virtual reality and off-shell existence, remember that photons serve as cosmic messengers carrying not just energy and information, but the very forces that structure matter and determine the evolution of stars, galaxies, and the universe itself through quantum processes that somehow give rise to the stable, predictable world of classical experience while maintaining their fundamentally probabilistic quantum character. Tonight we descend into the most bewildering realm of quantum reality, where photons exist in impossible states that defy classical physics and reveal the hidden infrastructure supporting all electromagnetic phenomena throughout the cosmos. Off-shell existence represents one of the most profound departures from ordinary experience, where virtual photons liberate themselves from the energy-momentum constraints that bind real particles, thanks to Heisenberg's uncertainty principle that permits temporary violations of conservation laws provided they occur within time intervals too brief for detection. Picture yourself witnessing phantom-like entities that can possess any combination of energy and momentum, regardless of whether these values satisfy the relationship E equals PC that governs real electromagnetic radiation, creating ghostly messengers that somehow mediate forces while existing in quantum limbo between possibility and actuality. Take a slow breath and contemplate this extraordinary freedom. Virtual photons escape the cosmic speed limit that confines their real counterparts, enabling them to carry information and momentum across space instantaneously, while maintaining consistency with relativistic causality through mathematical mechanisms that ensure no observable violation of light-speed communication barriers. The uncertainty principle provides the mathematical foundation for this apparent impossibility through the relationship delta E times delta T greater than or equal to h bar over 2, which permits energy fluctuations of arbitrary magnitude provided they disappear quickly enough to evade direct measurement, creating temporal windows where virtual particles can borrow energy from the quantum vacuum before repaying their debt to maintain overall conservation. This off-shell freedom transforms our understanding of electromagnetic interactions from mysterious action at a distance to concrete particle exchange processes where virtual photons carry definite amounts of energy and momentum between charged objects according to precise quantum mechanical calculations that predict every aspect of electrical and magnetic phenomena with unprecedented accuracy. The three polarizations available to virtual photons reveal another departure from classical expectations, as these quantum messengers possess longitudinal modes forbidden to real electromagnetic radiation in vacuum, enabling them to transmit forces along the direction of propagation in ways that would violate Maxwell's equations if applied to observable light waves. Unlike real photons restricted to transverse oscillations perpendicular to their direction of travel, virtual photons can vibrate parallel to their momentum vector, creating additional degrees of freedom that prove essential for mediating static electric fields and instantaneous Coulomb interactions between stationary charges separated by arbitrary distances. The mathematical framework describing virtual photon polarization involves gauge field configurations that exist only as intermediate states in quantum mechanical calculations, never appearing as final observable outcomes, but contributing crucially to the amplitudes that determine interaction probabilities and force strengths throughout electromagnetic theory. Modern experiments confirm these theoretical predictions through precision measurements of atomic energy levels, magnetic moments, and scattering cross-sections that match quantum electrodynamics calculations to extraordinary accuracy, demonstrating that virtual photons with their exotic polarization properties accurately describe the invisible mechanisms underlying all electromagnetic phenomena. The invisible infrastructure of virtual photon exchanges extends throughout every aspect of material existence, from the static electricity that makes your hair stand up to the radio waves carrying information across continents, revealing that apparently distinct phenomena emerge from universal quantum processes operating below the threshold of direct observation. Even the most mundane electromagnetic effects like the attraction between opposite charges or the repulsion of similar ones depend entirely on virtual photon exchanges that occur trillions of times per second, creating the stable forces that hold atoms together and determine the chemical properties of every element in the periodic table. The philosophical implications cascade through our understanding of reality itself, suggesting that what we perceive as continuous forces actually consist of discrete quantum transactions between particles and fields, transforming classical concepts of smooth interactions into granular processes that somehow give rise to the seamless phenomena we observe at macroscopic scales. Recent advances in cavity quantum electrodynamics have enabled researchers to manipulate virtual photon properties by confining electromagnetic fields between metallic mirrors, demonstrating practical control over the invisible infrastructure that governs atomic behavior and opening possibilities for engineering novel materials with customized electromagnetic responses. Perhaps most remarkably, virtual photons reveal that empty space itself participates actively in physical processes rather than serving as passive backdrop, with vacuum fluctuations contributing measurably to interaction strengths and energy levels throughout the universe, while remaining forever beyond direct detection through their off-shell existence. As we prepare to explore how virtual messengers create both attraction and repulsion, remember that these phantom particles represent the fundamental currency of electromagnetic interaction, invisible agents that somehow give rise to every electrical and magnetic phenomenon we observe, while maintaining their ghostly existence in the twilight realm between quantum possibility and classical actuality. Tonight we unravel one of nature's most perplexing paradoxes, where photons serve as cosmic messengers carrying electromagnetic forces throughout the universe, while remaining completely immune to the very interactions they facilitate, creating a profound mystery about how neutral entities can transmit the pushes and pulls that shape all matter and energy. The neutral messenger embodies perfect impartiality in its role as force carrier, possessing zero electric charge, yet somehow enabling every electromagnetic interaction from the attraction-binding electrons to atomic nuclei, to the repulsion-preventing solid objects from occupying identical locations in space. Picture yourself observing the invisible dance of virtual photons streaming between charged particles, these ghostly intermediaries carrying momentum and energy while remaining forever untouched by the electromagnetic fields they generate, like messengers who deliver letters without reading their contents or being affected by their emotional impact. Take a slow breath and contemplate this extraordinary neutrality. Photons can transmit electromagnetic effects across vast cosmic distances while experiencing none of these forces themselves, creating a universe where the mediators of interaction exist outside the realm of their own influence, untouchable agents in the cosmic drama of attraction and repulsion. The mechanism underlying force creation reveals astonishing elegance in how virtual photons with different energies produce opposite effects depending on the charges involved in any particular interaction, with positive energy exchanges generating repulsion between like charges, while negative energy transfers create attraction between opposite charges according to precise quantum mechanical calculations. This energy-dependent force generation emerges from the mathematical structure of quantum field theory, where virtual photon propagators carry different signs in their contributions to interaction amplitudes depending on whether they connect particles with identical or opposite charge configurations, automatically producing the correct force directions without requiring any additional assumptions about electromagnetic behavior. The quantum mechanical origin of attractive and repulsive forces eliminates the classical mystery of how opposite charges somehow know to attract each other across empty space, replacing mysterious action at a distance with concrete particle exchange processes, where virtual photons carry definite amounts of momentum transfer that create observed force effects through purely local interactions. Modern calculations reveal that repulsion between identical charges results from virtual photons carrying positive energy and momentum away from each particle, creating recoil effects that push them apart. While attraction between opposite charges emerges from virtual photons with negative energy components that effectively pull particles together through momentum transfer mechanisms that respect conservation laws, field manifestation provides the most profound insight into electromagnetic reality by revealing that static electric and magnetic fields consist entirely of collections of virtual photons frozen in time, unifying the apparently distinct concepts of continuous fields and discrete particles into a single quantum mechanical framework that describes both classical and quantum phenomena. This revolutionary perspective transforms our understanding of electric fields surrounding charged objects from mysterious invisible influences into concrete assemblages of virtual photons that exist in superposition states, ready to transfer momentum to any test charges introduced into their vicinity while maintaining their ghostly off-shell existence. The mathematical elegance underlying field-particle unification emerges from gauge field theory, which demonstrates that Maxwell's classical electromagnetic equations represent macroscopic averages of quantum photon behavior, with smooth field variations arising from statistical properties of vast numbers of virtual photons occupying all possible quantum states simultaneously. Recent experimental confirmations of virtual photon field structure include precision measurements of the Casimir effect, where boundaries modify virtual photon populations and create measurable forces between metallic plates, demonstrating that empty space itself participates actively in electromagnetic phenomena through its virtual particle content rather than serving as passive backdrop for classical field interactions. The technological applications of field-particle duality extend from magnetic resonance imaging systems that exploit quantum properties of electromagnetic field interactions with atomic nuclei to quantum electrodynamic calculations that enable precision predictions of atomic energy levels and transition probabilities used in laser technology and spectroscopic analysis. Perhaps most remarkably, the neutral messenger concept reveals fundamental symmetries in nature, where force carriers remain immune to their own interactions, a principle that extends beyond electromagnetism to include gluons in strong nuclear interactions and W and Z bosons in weak nuclear processes, suggesting universal patterns in how quantum fields mediate fundamental forces throughout the cosmos. The philosophical implications cascade through our understanding of causality and locality in quantum mechanics, where virtual photon exchanges somehow maintain consistency with relativistic requirements that no information travel faster than light, while enabling apparently instantaneous force transmission through off-shell particle propagation that operates outside normal energy momentum constraints. As we prepare to explore deeper mysteries of quantum field mathematics and gauge symmetries, remember that virtual photons represent the invisible threads that weave together all electromagnetic phenomena in the universe. Neutral agents carrying the forces that determine atomic structure, chemical bonding, and the evolution of stars while remaining forever beyond direct observation in their ghostly existence between quantum possibility and classical reality. Tonight we ascend to the pinnacle of mathematical elegance, where abstract equations somehow capture the deepest secrets of electromagnetic reality, revealing how quantum field theory transforms Maxwell's classical descriptions into precise predictions about photon behavior that match experimental observations with breathtaking accuracy. Maxwell meets quantum through a revolutionary synthesis that demonstrates how 19th century electromagnetic theory emerges naturally from quantum mechanical descriptions of photon wave functions, connecting the smooth field oscillations that Maxwell envisioned with the granular particle exchanges that quantum theory demands through mathematical transformations of stunning beauty and power. Picture yourself witnessing the moment when classical physics dissolves into quantum mechanics as field variables become operator-valued functions that create and destroy photons according to precise algebraic rules, transforming continuous electromagnetic waves into discrete quantum processes while preserving all the successful predictions of classical electromagnetism. Take a slow breath and contemplate this extraordinary mathematical achievement. Every aspect of electromagnetic behavior, from radio wave propagation to atomic energy levels, can be calculated using quantum field equations that treat photons as excitations of underlying fields, demonstrating that abstract mathematical structures somehow encode the fundamental laws governing light and matter throughout the cosmos. The emergence of Maxwell equations from quantum theory occurs through a process called the classical limit, where quantum field operators reduce to ordinary functions when dealing with large numbers of photons in coherent states, revealing that classical electromagnetic theory represents a macroscopic approximation to more fundamental quantum processes that operate at microscopic scales. Second quantization represents perhaps the most profound conceptual leap in theoretical physics, converting classical field variables into quantum operators that can add or remove particles from existence through purely mathematical manipulations governed by commutation relations that encode conservation laws and uncertainty principles into the algebraic structure of field theory itself. This revolutionary procedure transforms electromagnetic field components into creation and annihilation operators that satisfy canonical commutation brackets, enabling physicists to calculate probabilities for photon emission, absorption, and scattering processes through operator algebra that somehow captures the essential features of quantum reality despite its abstract mathematical nature. The mathematical beauty underlying quantum electrodynamics emerges through Lagrangian field theory, where electromagnetic interactions arise from gauge symmetry principles that determine the form of field equations through elegant variational calculations, demonstrating that nature operates according to mathematical principles of extraordinary depth and universality that connect quantum mechanics to classical physics through continuous mathematical transformations. Paul Dirac's original formulation of quantum electrodynamics revealed how photon creation and annihilation emerge naturally from applying quantum mechanical principles to Maxwell's electromagnetic field equations, establishing a theoretical framework that has remained essentially unchanged despite decades of experimental tests and theoretical refinements that have pushed its predictions to unprecedented levels of precision. Modern calculations using quantum field theory achieve remarkable accuracy in predicting phenomena like the anomalous magnetic moment of electrons, where virtual photon corrections modify classical values by tiny amounts that have been measured and calculated to better than 12 decimal places, demonstrating perfect agreement between abstract mathematical formalism and concrete experimental reality. The computational techniques developed for quantum electrodynamics have revolutionized theoretical physics by providing systematic methods for calculating interaction probabilities through Feynman diagrams that represent complex mathematical expressions as intuitive pictures, where particle world lines and photon exchanges visualize quantum processes that would otherwise remain buried in impenetrable algebraic manipulations. Perhaps most remarkably, abstract equations predict physical reality with such stunning precision that theoretical calculations often anticipate experimental discoveries, as when quantum field theory predicted the existence of antimatter, vacuum polarization effects, and spontaneous photon emission decades before these phenomena could be directly observed through laboratory measurements. The philosophical implications extend far beyond physics into fundamental questions about the relationship between mathematics and reality, suggesting that abstract mathematical structures may represent more than mere human constructs for describing natural phenomena, but rather fundamental aspects of reality itself that somehow give rise to the physical universe through mechanisms that remain deeply mysterious. Recent advances in quantum field theory have extended these mathematical methods to describe all known fundamental forces and particles through gauge field theories that treat electromagnetic, weak nuclear, and strong nuclear interactions as different manifestations of underlying symmetry principles, revealing remarkable unity in the mathematical structures that govern all physical phenomena from subatomic to cosmic scales. The technological applications emerging from quantum field calculations enable innovations ranging from precision atomic clocks that exploit calculated energy level spacings to quantum computers that manipulate photon states according to theoretical predictions about quantum entanglement and superposition, demonstrating practical mastery over phenomena that exist purely as mathematical abstractions until manifested through experimental apparatus. As we prepare to explore deeper mysteries of gauge symmetries and renormalization procedures, remember that quantum field equations represent humanity's most successful attempt to capture the mathematical essence of electromagnetic reality. Abstract formulations that somehow encode the behavior of every photon in the universe while maintaining their ethereal existence as pure mathematical relationships that bridge the gap between human understanding and cosmic truth. Tonight we penetrate the deepest mysteries of electromagnetic theory, where hidden symmetries govern the fundamental structure of reality itself, revealing that nature operates according to mathematical principles so elegant they determine which particles can exist and which forces can propagate throughout the cosmos. Hidden symmetries emerge as perhaps the most profound discovery in modern physics, demonstrating that electromagnetic theory remains completely unchanged under gauge transformations that modify field descriptions without affecting any observable physical phenomena, suggesting that multiple mathematical representations can describe identical reality through coordinate freedom that reflects fundamental properties of spacetime itself. Picture yourself observing electromagnetic fields from different mathematical perspectives, each viewpoint revealing identical physical predictions despite using completely different mathematical variables, like viewing the same landscape through coloured filters that change appearance without altering the underlying terrain being observed. Take a slow breath and contemplate this extraordinary invariance. Gauge transformations allow physicists to add arbitrary functions to electromagnetic potentials without changing electric and magnetic field configurations, demonstrating that nature distinguishes between mathematical convenience and physical reality in ways that preserve essential physics while permitting infinite equivalent descriptions. The mathematical elegance underlying gauge symmetry emerges through differential geometry where electromagnetic fields represent curvature in abstract spaces, with gauge transformations corresponding to coordinate changes that preserve geometric relationships while altering numerical representations, revealing deep connections between electromagnetic theory and the mathematical structures that describe curved spacetime in general relativity. Hermann Weyl first recognized gauge symmetry in electromagnetic theory during the 1920s, proposing that scale transformations might provide fundamental insights into quantum mechanics and gravitation, though his original ideas required modification before achieving the modern understanding that connects gauge invariance to conservation laws through Emmy Noether's revolutionary theorem linking symmetries to conserved quantities. Mass and symmetry reveal an iron law of physics that forbids photons from possessing rest mass, because any photon mass term would violate gauge invariance by introducing physical effects that depend on arbitrary coordinate choices, demonstrating that mathematical consistency requirements determine which particles can exist in nature rather than experimental observations alone. This profound constraint emerges because massive vector particles require three polarization states, including a longitudinal mode that transforms under gauge changes, while gauge invariance demands that physical observables remain independent of mathematical gauge choices, creating an incompatibility that can only be resolved by requiring exact masslessness for electromagnetic field quanta. The theoretical necessity of massless photons has been confirmed experimentally through precision tests that place upper bounds on photon mass as smaller than 1 part in 10 to the 18th power of electron mass, demonstrating remarkable agreement between mathematical requirements and physical reality, while establishing gauge invariance as a fundamental principle governing electromagnetic interactions. Conservation laws emerge from gauge symmetry through Noether's theorem, which reveals that electric charge conservation throughout the universe follows automatically from the requirement that electromagnetic theory remain invariant under local gauge transformations, connecting abstract, mathematical symmetries to concrete physical conservation principles that operate from subatomic to cosmic scales. This profound relationship demonstrates that charge conservation represents more than an empirical observation about electric phenomena, but rather a mathematical necessity that emerges from the gauge structure of electromagnetic field equations, ensuring that electric charge can neither be created nor destroyed in any physical process, while permitting charge transfer between particles through electromagnetic interactions. Modern particle physics extends gauge symmetry principles to describe weak nuclear forces through electroweak unification and strong nuclear interactions through quantum chromodynamics, revealing that all fundamental forces emerge from gauge symmetry requirements that determine particle properties, interaction strengths, and conservation laws through mathematical principles of extraordinary universality and power. The philosophical implications cascade through every aspect of theoretical physics, suggesting that mathematical symmetries may represent more fundamental aspects of reality than particles and forces themselves, with observable phenomena emerging as manifestations of underlying geometric structures that exist independently of human mathematical constructions, while somehow determining the evolution of stars, galaxies, and consciousness itself. Recent advances in gauge field theory have revealed connections between electromagnetic symmetries and exotic phenomena like magnetic monopoles, topological insulators, and quantum Hall effects, demonstrating that gauge invariance continues yielding new insights into condensed matter, physics, cosmology, and fundamental particle interactions despite nearly a century of intensive theoretical and experimental investigation. Perhaps most remarkably, gauge symmetry provides the mathematical foundation for quantum field theory with normalization procedures that eliminate infinite quantities from theoretical calculations while preserving finite physical predictions, enabling precise numerical agreements between theory and experiment that would be impossible without the mathematical consistency guaranteed by gauge invariance principles. As we prepare to explore the mysteries of renormalization and infinite cancellations, remember that gauge symmetry represents humanity's deepest insight into the mathematical structure of electromagnetic reality, revealing that nature operates according to geometric principles that somehow give rise to conservation laws, particle properties, and the stable physical structures we observe, while maintaining their abstract mathematical existence beyond direct experimental access. Tonight we witness one of the most miraculous rescues in the history of theoretical physics, where mathematical techniques transform seemingly fatal infinite quantities into finite predictions that match experimental reality with unprecedented precision, revealing the hidden order beneath apparent chaos in quantum field calculations. Infinite problems plagued early quantum electrodynamics when physicists attempted to calculate higher-order corrections involving virtual particle loops, discovering that these contributions yielded mathematically meaningless infinite results that threatened to destroy the entire theoretical framework despite its remarkable success in describing basic electromagnetic phenomena. Picture yourself confronting equations that spiral into mathematical infinity whenever virtual photons create temporary electron-positron pairs, or when electrons emit and reabsorb their own virtual photons, creating loops of quantum activity that generate divergent integrals, requiring entirely new mathematical approaches to extract finite physical predictions from seemingly hopeless calculations. Take a slow breath and contemplate this extraordinary challenge. The very quantum corrections that should provide the most precise predictions about electromagnetic interactions initially appeared to destroy the mathematical foundation of field theory through infinite contributions that made no physical sense, threatening to invalidate humanity's most successful description of fundamental forces. The solution emerged through renormalization techniques developed independently by Richard Feynman, Julian Schwinger, and Shinichiro Tominaga during the late 40s. Revolutionary mathematical procedures that systematically remove infinite quantities while preserving all finite physical predictions through carefully constructed subtraction schemes that somehow extract meaningful results from apparently meaningless expressions. This remarkable mathematical rescue operation works by recognizing that infinite contributions arise from integrating over all possible energies and momenta in virtual particle loops, with divergences appearing when these integrations extend to arbitrarily high values that correspond to physics beyond the domain where current theories should be expected to remain valid. The renormalization procedure involves introducing cutoff parameters that limit integrations to finite ranges, calculating observable quantities as functions of these cutoffs, then defining physical parameters through subtraction schemes that eliminate cutoff dependence while preserving finite differences that correspond to measurable effects. Modern understanding reveals that renormalization represents more than mathematical trickery, but rather reflects fundamental aspects of quantum field theory, where measurable quantities emerge as differences between infinite background contributions and finite physical corrections, suggesting that absolute values may be less fundamental than relative changes in quantum systems. The physical meaning underlying renormalization becomes clear when examining how virtual photons measurably modify electron properties through quantum corrections that shift magnetic moments, energy levels, and interaction. strengths by tiny amounts that can be calculated theoretically and measured experimentally with extraordinary precision using modern atomic physics techniques. The anomalous magnetic moment of electrons provides the most stunning demonstration of renormalization success, where quantum electrodynamics calculations, including virtual photon corrections, predict values that differ from classical expectations by approximately 0.001 magnetic units, a prediction confirmed experimentally to better than 12 decimal places through precision measurements using magnetic resonance techniques. This remarkable agreement between theory and experiment extends to other quantum corrections like the Lamb shift in hydrogen atoms, where virtual photon effects modify energy levels by minute amounts that can be calculated from first principles and verified through high-resolution spectroscopy, demonstrating that renormalization procedures capture genuine physical effects rather than merely mathematical artifacts. The mathematical elegance underlying renormalization emerges through the recognition that physical theories should remain independent of arbitrary mathematical choices like energy cutoffs or regularization schemes, leading to sophisticated techniques that preserve this independence while extracting finite predictions from divergent calculations through systematic elimination of scheme-dependent contributions. Recent advances in quantum field theory have revealed that renormalization procedures apply universally across all fundamental interactions, from electromagnetic forces described by quantum electrodynamics to strong nuclear forces governed by quantum chromodynamics, suggesting that infinite cancellations represent essential features of quantum reality, rather than peculiarities of particular theoretical frameworks. The technological applications of renormalization extend from precision atomic clocks that rely on calculated energy level shifts to quantum computing schemes that exploit calculated interaction strengths, demonstrating practical benefits from mathematical techniques that initially appeared to threaten the entire theoretical foundation of quantum field theory. Perhaps most remarkably, renormalization reveals that virtual particles produce measurable physical effects despite their ephemeral existence, with quantum corrections from photon loops contributing observably to electron behavior in ways that can be predicted theoretically and confirmed experimentally, bridging the gap between abstract mathematical formalism and concrete physical reality. As we prepare to explore deeper mysteries of photon wave functions and quantum properties, remember that renormalization represents humanity's most sophisticated mathematical achievement in theoretical physics, enabling precise predictions about electromagnetic phenomena through techniques that transform infinite chaos into finite order while revealing the hidden mathematical structures that somehow govern the behavior of matter and energy throughout the cosmos. Tonight we venture into the most perplexing mathematical territory in all of quantum mechanics, where the very concept of photon wave functions collides with relativistic requirements to create paradoxes that have challenged physicists for nearly a century and continue to reveal fundamental limitations in our mathematical descriptions of light itself. Relativistic challenges emerge immediately when attempting to construct wave functions for massless particles that travel permanently at light speed, creating insurmountable difficulties because standard quantum mechanical procedures assume particles can be brought to rest and described using position coordinates that become meaningless when applied to entities that exist only in perpetual motion. Picture yourself trying to pin down the location of something that never stops moving, never slows down, and exists only as pure kinetic energy racing through spacetime at the cosmic speed limit, revealing why conventional wave function formalism breaks down completely when confronted with the ethereal nature of electromagnetic radiation. Take a slow breath and contemplate this extraordinary mathematical puzzle. Photons resist description through the familiar wave functions that work perfectly for electrons and other massive particles, because massless entities cannot be localized in space without violating fundamental principles of special relativity that forbid assigning rest frames to objects traveling at light speed. The mathematical framework underlying photon description requires abandoning traditional approaches that treat particles as localized entities with definite positions and momenta, instead embracing field-theoretic methods that describe electromagnetic radiation as excitations of underlying fields rather than discrete objects moving through space according to classical trajectories. Alternative descriptions emerge through sophisticated mathematical constructions like Riemann-Silberstein vectors that combine electric and magnetic field components into complex three-dimensional objects, whose modulus squared provides probability densities for photon detection at various spacetime points, creating wave-like descriptions that preserve the essential physics while avoiding the mathematical inconsistencies that plague simpler approaches. These vector formulations treat photons as purely transverse oscillations in six-dimensional spaces that project onto ordinary three-dimensional reality through geometric relationships that somehow encode polarization properties, energy distributions, and propagation characteristics into mathematical structures that transcend ordinary spatial intuition. The electromagnetic field amplitude approach provides another pathway for describing photon quantum states through classical field configurations that satisfy Maxwell equations while carrying discrete energy quanta, revealing connections between quantum, particle descriptions and classical wave theory that bridge seemingly incompatible theoretical frameworks through mathematical transformations of remarkable elegance and power. Modern developments in photon wave function theory have revealed that these mathematical descriptions can be made consistent provided we abandon classical notions of particle trajectories and embrace purely field-theoretic perspectives where photons emerge as transient disturbances in electromagnetic field configurations rather than persistent objects with continuous existence through time and space. The position problem represents perhaps the deepest challenge in photon quantum mechanics because defining location for entities that travel at light speed requires mathematical procedures that violate basic principles of quantum measurement theory, which assumes that position and momentum observables can be simultaneously meaningful even if they cannot be simultaneously measured with perfect precision. This fundamental difficulty arises because photons experience no proper time during their journey from emission to absorption, existing in a timeless realm where the entire universe contracts to zero extent along their direction of travel, creating mathematical descriptions that must somehow capture this relativistic perspective while remaining meaningful for observers in ordinary reference frames. Recent advances in quantum optics have developed practical methods for manipulating single photons despite these theoretical complications, using cavity quantum electrodynamics and nonlinear optical processes to create, control, and detect individual light quanta, while avoiding direct confrontation with the mathematical inconsistencies that emerge from attempts to assign definite spatial locations to massless particles. Perhaps most remarkably, these mathematical challenges reveal fundamental limitations in human conceptual frameworks rather than failures of physical reality, suggesting that photons exist in domains that transcend ordinary spatial and temporal categories while maintaining their essential role as carriers of electromagnetic energy and information throughout the cosmos. The philosophical implications extend far beyond technical mathematics into questions about the nature of existence itself, challenging assumptions about objects, properties, and locations while revealing that reality may operate according to principles that cannot be captured completely through any single mathematical formalism, however sophisticated or elegant. As we prepare to explore deeper mysteries of photon quantum numbers and internal structure, remember that wave function difficulties represent windows into the fundamental strangeness of quantum reality, rather than mere technical obstacles, revealing that light exists in realms beyond classical description, while somehow giving rise to all the familiar electromagnetic phenomena that structure our everyday experience of the physical world. Tonight we unlock the quantum secrets encoded within photon architecture, where intrinsic angular momentum and polarization states reveal the fundamental mathematical structure that governs every electromagnetic interaction from atomic transitions to cosmic radiation across the vast expanse of space-time. Spin-1 nature emerges as one of the most profound characteristics defining photon identity, demonstrating that these massless messengers carry exactly 1 unit of intrinsic angular momentum measured in units of h-bar, placing them in the category of vector particles that possess directional properties fundamentally different from scalar entities or higher spin objects. Picture yourself observing a photon as it spirals through space, with its internal angular momentum creating clockwise or counterclockwise rotations that remain forever locked to its direction of propagation, revealing quantum mechanical properties that have no classical analogue yet determine every aspect of electromagnetic radiation from radio waves to gamma rays. Take a slow breath and contemplate this extraordinary quantum characteristic. Photons possess angular momentum that cannot be separated from their motion, creating spinning messengers that carry rotational energy across cosmic distances while maintaining perfect correlation between their spin orientation and propagation direction according to relativistic requirements that unite space, time, and angular momentum into inseparable quantum entities. The vector nature of photons manifests through their ability to exist in superposition states of different polarizations, enabling quantum interference effects and entanglement phenomena that form the foundation of modern quantum optics and quantum information technologies that exploit these intrinsic rotational properties for revolutionary applications in computing, cryptography, and precision measurement. Two polarizations represent the complete set of quantum states available to real photons in free space, corresponding to left and right circular polarizations that describe the sense of rotation as electromagnetic fields spiral around the direction of propagation, creating the fundamental basis states from which all possible photon polarizations can be constructed through quantum superposition. This binary choice emerges from relativistic constraints that eliminate the third polarization state available to massive vector particles, demonstrating how special relativity determines quantum mechanical possibilities by forbidding longitudinal oscillations for massless entities that travel permanently at light speed through the cosmic medium. The missing spin theory component reveals deep connections between relativity and quantum mechanics, showing how spacetime geometry constrains quantum state spaces and eliminates mathematical possibilities that would violate fundamental physical principles, creating a universe where photon properties are determined by the intersection of quantum mechanics with relativistic requirements. Linear polarizations familiar from everyday optical phenomena emerge as quantum superpositions of circular states, with horizontal, vertical, and diagonal orientations representing different combinations of left and right circular components that can be analyzed and manipulated using polarizing filters, wave plates, and other optical devices that exploit the quantum nature of electromagnetic radiation. Selection rules governing atomic transitions provide the most direct manifestation of photon quantum numbers in observable phenomena, determining which electron energy level changes can occur through photon emission or absorption based on conservation of angular momentum, parity, and other quantum symmetries that must be preserved in all electromagnetic interactions. These fundamental constraints explain why certain atomic transitions produce bright spectral lines, while others remain completely forbidden, creating the distinctive fingerprints of chemical elements that enable astronomical spectroscopy and reveal the composition of distant stars, galaxies, and interstellar gas clouds through analysis of their electromagnetic radiation. The mathematical framework underlying selection rules connects photon spin properties to atomic angular momentum through sophisticated group theory calculations that predict transition probabilities, polarization characteristics, and spectral intensities with remarkable precision, demonstrating deep mathematical unity between quantum mechanics, electromagnetism, and atomic physics. Modern applications of photon quantum properties extend from laser systems that exploit stimulated emission between specific atomic levels to quantum dots and artificial atoms, where engineered selection rules enable custom optical responses for applications ranging from solar cells to quantum computers that manipulate individual photons according to their intrinsic quantum numbers. Perhaps most remarkably, photon quantum properties reveal fundamental connections between local atomic processes and global electromagnetic field configurations, showing how microscopic quantum numbers determine macroscopic optical phenomena through statistical averaging over vast numbers of quantum transitions that somehow give rise to the classical electromagnetic waves described by Maxwell equations. The philosophical implications extend into questions about the relationship between discrete quantum properties and continuous classical fields, suggesting that photon quantum numbers represent fundamental aspects of reality that cannot be reduced to classical descriptions, while somehow giving rise to all the familiar electromagnetic phenomena that structure our technological civilization. As we prepare to explore deeper mysteries of photon internal structure and virtual quark content, remember that quantum numbers encode the essential mathematical information that determines how photons interact with matter and energy throughout the universe while maintaining their ethereal existence as massless carriers of electromagnetic force and information across the cosmic void. Tonight we descend into the most bewildering revelation about photon nature, where massless particles of pure electromagnetic energy somehow contain the building blocks of matter itself through quantum processes that challenge every assumption about emptiness and substance in the deepest foundations of reality. The quark paradox emerges when high-energy photons undergo spontaneous transformations that temporarily split their ethereal essence into virtual matter-antimatter pairs, creating fleeting quark-antiquark configurations that exist for impossibly brief moments before reuniting to restore the original massless state through processes that defy classical understanding. Picture yourself witnessing electromagnetic energy momentarily crystallizing into the fundamental constituents of protons and neutrons, those mysterious quarks that normally remain forever confined within atomic nuclei, yet somehow materialize from pure light when sufficient energy concentrations trigger quantum fluctuations that blur the boundary between force and matter. Take a slow breath and contemplate this extraordinary phenomenon. Photons that appear completely empty and structureless reveal measurable internal architecture when probed at extreme energies, demonstrating that even massless entities possess hidden complexity through virtual particle configurations that contribute observably to electromagnetic interactions despite their ephemeral existence. The quantum mechanical origin of photon structure emerges through field theory calculations that describe how electromagnetic energy can spontaneously convert into quark-antiquark pairs through virtual processes permitted by uncertainty principle fluctuations, creating temporary matter configurations that modify photon behavior in ways detectable through precision scattering experiments. Experimental evidence from particle accelerator facilities at DESY, CERN, and other high-energy physics laboratories has confirmed photon structure through deep inelastic scattering experiments where energetic electrons probe the interior of photons by colliding with their virtual quark content, revealing pattern distribution functions that describe the probability of finding specific quark types with particular momentum fractions inside photonic targets. These groundbreaking measurements demonstrate that photons behave like composite objects containing virtual up quarks, down quarks, strange quarks, and their corresponding antiquarks in fluctuating configurations that somehow emerge from pure electromagnetic field energy through quantum processes that connect force carriers to matter constituents in previously unimaginable ways. The experimental technique involves firing high-energy electron beams at photon targets created through intense laser pulses or electromagnetic field configurations, then analyzing the scattered particles to reconstruct information about photon internal structure through statistical analysis of thousands of collision events that reveal the underlying quark-antiquark distributions. Timescale mystery adds another layer of bewilderment to photon structure, because virtual quark pairs exist for only 10 to the minus 23 seconds, duration so brief that light travels mere femtometers during their entire existence, creating matter configurations that appear and disappear faster than any classical process could possibly detect, yet somehow contribute measurably to photon properties through quantum interference effects. This incredibly short lifetime emerges from uncertainty principle constraints that permit energy fluctuations sufficient to create massive quark pairs only for time intervals inversely related to their rest masses, ensuring that virtual matter configurations must disappear almost immediately to avoid violating conservation laws that govern all physical interactions. The spatial extent of virtual quark pairs reaches only microscopic distances measured in femtometers, smaller than atomic nuclei, yet sufficient to create detectable modifications in photon structure functions that can be measured through precision, accelerator experiments and calculated using quantum chromodynamics theory that describes strong interactions between quarks and gluons. Modern theoretical frameworks describe photon structure through sophisticated calculations that treat electromagnetic radiation as superposition, states containing virtual hadronic components, revealing deep connections between quantum electrodynamics and quantum chromodynamics that unify electromagnetic forces with strong nuclear interactions through shared quark content in virtual particle configurations. Perhaps most remarkably, photon structure demonstrates that the classical distinction between matter and energy dissolves at quantum scales where electromagnetic radiation contains virtual matter, while massive particles like protons contain virtual photon configurations, creating a universe where force and substance represent different aspects of underlying quantum field dynamics rather than fundamentally distinct categories. The philosophical implications cascade through every aspect of particle physics and cosmology, suggesting that apparently empty photons participate in the same quantum processes that create atomic nuclei, while massless electromagnetic radiation shares essential features with massive hadronic matter through virtual particle exchanges that operate below the threshold of classical observation. As we prepare to explore deeper mysteries of photon interactions and matter creation, remember that internal structure reveals photons as far more complex entities than their massless nature might suggest, containing within their ethereal essence the virtual seeds of all strongly interacting matter, while maintaining their essential role as carriers of electromagnetic force and information across the cosmic distances that separate stars, galaxies, and consciousness itself. Tonight we explore the cosmic ballet where photons collide with matter in a symphony of interactions that sculpt the appearance of our universe, from the deep blue of afternoon skies to the crimson glory of twilight horizons, revealing how electromagnetic radiation dances with electrons through quantum processes that determine the very colours we perceive. Compton scattering emerges as perhaps the most dramatic photon-electron encounter, where high-energy electromagnetic radiation strikes free electrons and transfers portions of its energy and momentum according to relativistic mechanics described by the Klein-Nishina formula, creating measurable wavelength shifts that provided some of the earliest definitive proof of photon particle nature. Picture yourself witnessing X-ray photons as they collide with electrons like cosmic billiard balls, each impact transferring precise amounts of energy determined by scattering angle and initial photon frequency, creating longer wavelength radiation that emerges from the collision zone carrying reduced energy, while the recoiling electrons gain kinetic motion in perfect accordance with conservation principles. Take a slow breath and contemplate this extraordinary process. The wavelength increase depends exclusively on scattering angle through the Compton wavelength formula, demonstrating that photons behave as discrete particles during collisions, while simultaneously maintaining their wave-like propagation characteristics between interactions according to quantum mechanical duality that defies classical description. The Klein-Nishina cross-section provides theoretical predictions for Compton scattering probabilities that match experimental observations with remarkable precision across all photon energies from soft X-rays to hard gamma radiation, establishing quantum electrodynamics as the most accurate theoretical framework ever developed for describing electromagnetic phenomena at microscopic scales. Thomson scattering represents the low-energy limit where photon wavelengths remain unchanged during electron interactions, creating elastic collisions that redirect electromagnetic radiation without energy transfer, while preserving both photon frequency and electron rest state through processes that dominated early universe evolution before hydrogen recombination. This coherent scattering mechanism operates when photon energies fall far below electron rest mass, enabling classical electromagnetic theory to provide accurate descriptions of radiation-matter interactions through oscillating dipole models where electrons respond to electric field oscillations by radiating electromagnetic waves at identical frequencies. The Thomson regime explains how free electrons in stellar atmospheres and interstellar plasma scatter starlight without altering its spectral characteristics, creating polarization effects and intensity modifications that astronomers exploit to study magnetic field configurations and electron densities throughout cosmic environments from solar coronas to galactic halos. Rayleigh scattering unveils the quantum origin of atmospheric optics through photon interactions with bound electrons in gas molecules, where shorter blue wavelengths experience stronger scattering than longer red wavelengths according to the fourth power dependence that transforms white sunlight into the azure dome that crowns our planet. This wavelength-dependent phenomenon emerges because molecular electrons oscillate more vigorously in response to higher frequency electromagnetic fields, creating enhanced radiation emission in all directions that preferentially removes blue light from direct solar beams, while enriching scattered skylight with shorter wavelengths that paint the heavens in brilliant cobalt hues. The mathematical framework underlying Rayleigh processes involves polarizability calculations that describe how electromagnetic fields induce oscillating electric dipoles in atoms and molecules, with scattering intensities proportional to the sixth power of frequency divided by the fourth power of wavelength, creating the wavelength selectivity that generates both blue skies and red sunsets through complementary filtering effects. Sunset coloration emerges when sunlight traverses extended atmospheric paths that gradually remove blue wavelengths through multiple scattering events, leaving predominantly longer red and orange wavelengths to reach observers directly, while creating the spectacular crimson displays that have inspired countless generations of humans to contemplate the beauty hidden within electromagnetic wave interactions. Modern applications of scattering phenomena extend from medical imaging techniques that exploit Compton interactions for diagnostic purposes to atmospheric remote sensing systems that analyze scattered radiation to determine pollution levels, particle concentrations, and meteorological conditions throughout the Earth's gaseous envelope. Perhaps most remarkably, scattering processes reveal fundamental connections between microscopic quantum interactions and macroscopic optical phenomena, demonstrating how individual photon-electron collisions somehow give rise to the familiar visual experiences that structure human perception of color, brightness, and atmospheric beauty through statistical averaging over countless quantum events. As we prepare to explore atomic emission and absorption processes, remember that scattering phenomena connect the ethereal realm of electromagnetic radiation to the tangible world of matter through quantum interactions that determine everything from medical X-ray imaging to the magnificent colors that paint our skies, while revealing the hidden quantum choreography underlying all electromagnetic wave propagation through material media. Tonight we witness the most intimate conversations between light and matter, where atoms and photons exchange energy through quantum dialogues that have shaped the evolution of stars, galaxies, and the very elements that compose our bodies through processes of breathtaking precision and mathematical elegance. Emission and absorption represent the fundamental currency of electromagnetic interaction, where electrons jumping between discrete energy levels within atomic orbitals either release or capture photons with frequencies precisely matched to the energy differences that separate quantum states according to Planck's revolutionary relationship between frequency and quantum energy. Picture yourself observing an excited hydrogen atom as its electron cascades from higher to lower energy levels, spontaneously emitting photons whose wavelengths correspond exactly to the Balmer, Lyman, or Paschen series that create the distinctive spectroscopic fingerprints astronomers use to identify elements throughout the cosmos, from nearby stellar atmospheres to distant quasar emission regions. Take a slow breath and contemplate this extraordinary precision. Atomic energy levels are quantized so exactly that photon frequencies match electronic transitions to better than 1 part in 10 billion, creating spectroscopic standards that define fundamental units of time, length, and frequency, while enabling technologies from atomic clocks to laser cooling systems that manipulate matter at quantum scales. The mathematical framework underlying atomic transitions involves selection rules that govern which electron jumps can occur based on conservation of angular momentum, parity, and other quantum symmetries, ensuring that not all conceivable energy level changes produce observable spectral lines while creating the rich variety of emission and absorption features that characterize each chemical element. Spontaneous decay emerges as one of the most mysterious quantum phenomena, where excited atoms naturally return to ground states by emitting photons even in the complete absence of external electromagnetic fields, a process that cannot be explained using classical physics, but requires quantum field theory to describe how atoms couple to vacuum fluctuations in the electromagnetic field. This remarkable phenomenon demonstrates that empty space itself participates actively in atomic processes through zero-point oscillations that provide the quantum mechanical driving force for spontaneous photon emission, revealing deep connections between vacuum energy and atomic stability that operate continuously throughout the universe wherever excited matter exists. The exponential decay law governing spontaneous emission reflects the probabilistic nature of quantum mechanics, where identical excited atoms emit photons at random times, according to statistical distributions characterized by well-defined lifetimes that range from nanoseconds for strongly allowed transitions to hours or years for forbidden processes that violate normal selection rules. Einstein's brilliant insight into stimulated emission revolutionized our understanding of light-matter interactions by revealing that photons can trigger identical photon emission from excited atoms, creating coherent radiation amplification that forms the theoretical foundation for laser technology and has transformed fields ranging from telecommunications to precision manufacturing through controlled electromagnetic field generation. The stimulated emission process requires that incident photons possess exactly the right frequency to match atomic transition energies, whereupon excited electrons drop to lower levels, while emitting additional photons that share identical frequency, phase, and polarization characteristics with the stimulating radiation, creating cascading amplification effects when population inversions concentrate atoms in excited states. Modern laser systems exploit stimulated emission through carefully engineered gain media, where more atoms occupy excited states than ground states, violating thermal equilibrium through external pumping mechanisms that create the inverted populations necessary for coherent light amplification, according to Einstein's original theoretical predictions from the early 20th century. The technological applications of controlled atomic transitions extend from medical laser surgery that exploits specific absorption wavelengths to quantum computing schemes that manipulate atomic energy levels for information processing, demonstrating practical mastery over the quantum processes that govern light-matter interactions at the most fundamental scales, accessible to human engineering. Perhaps most remarkably, atomic interactions reveal that photons and electrons engage in perfectly choreographed quantum dances, where energy conservation, momentum conservation, and angular momentum conservation all operate simultaneously to ensure that every electromagnetic transition preserves the mathematical symmetries of what govern physical reality, while enabling the rich variety of spectroscopic phenomena that astronomers observe throughout cosmic evolution. The astrophysical implications include stellar nucleosynthesis processes where atomic transitions enable energy transport from stellar cores to surface regions, planetary nebula formation where forbidden line transitions create spectacular emission displays, and cosmic microwave background radiation that emerged from hydrogen recombination when the early universe became transparent to electromagnetic radiation. As we prepare to explore the ultimate nature of photons and the deepest mysteries of quantum reality, remember that atomic interactions connect the microscopic realm of quantum mechanics to the macroscopic world of classical experience through electromagnetic processes that somehow give rise to the stable matter, structures enabling stars, planets, and consciousness, while maintaining their fundamentally quantum mechanical character that transcends ordinary description. Tonight we ascend to the technological pinnacle where humanity has achieved mastery over individual photons, transforming abstract quantum theories into revolutionary devices that exploit the deepest secrets of electromagnetic radiation to create tools that would have seemed like pure magic to earlier generations of scientists and engineers. Laser precision represents the triumph of the controlled stimulated emission, where electromagnetic radiation achieves perfect coherence through population inversion techniques that concentrate atoms in excited states, enabling photons to trigger cascading amplification processes that produce monochromatic beams with extraordinary intensity, directionality, and temporal stability unmatched by any natural light source. Picture yourself witnessing the birth of coherent light within laser cavities where mirrors trap photons in resonant configurations, forcing them to stimulate identical emission events that build exponentially until brilliant beams emerge with wavelengths so pure they enable interferometric measurements accurate to fractions of atomic dimensions and surgical procedures that can reshape corneas or destroy cancer cells with submicron precision. Take a slow breath and contemplate this extraordinary achievement. Modern laser systems can generate photon streams so perfectly synchronized that their electromagnetic waves remain in phase across distances spanning continents, enabling gravitational wave detection through interferometry, sensitive enough to measure spacetime distortion to smaller than 1/10,000th the width of a proton. The technological applications of laser coherence extend from industrial cutting and welding operations that exploit focused intensity to optical fiber communication systems that carry terabits of information through photonic networks spanning global distances, demonstrating practical mastery over electromagnetic properties that operate according to quantum mechanical principles while serving classical engineering purposes. Quantum computing harnesses individual photons as carriers of quantum information through superposition states that enable parallel processing across multiple computational pathways simultaneously, creating revolutionary computational architectures that could solve certain problems exponentially faster than classical computers by exploiting quantum entanglement and interference effects between carefully controlled photonic qubits. These photonic quantum computers manipulate individual light quanta through networks of beam splitters, phase shifters, and photon detectors that perform logical operations on quantum superposition states. enabling algorithms for cryptography, optimization, and simulation problems that remain intractable for conventional digital computers despite decades of technological advancement. The quantum communication protocols enabled by single photon manipulation provide ultimate security for information transmission through quantum key distribution systems where any attempt to intercept photons automatically disturbs their quantum states, revealing eavesdropping attempts through fundamental physical principles rather than mathematical complexity that could potentially be overcome by future algorithmic breakthroughs. Single photon detection represents perhaps the most remarkable technological achievement in experimental physics, where ultra-sensitive devices can register the arrival of individual light quanta, with efficiencies approaching 100% while preserving their quantum properties for subsequent manipulation and measurement through sophisticated optical systems. Modern single-photon detectors exploit avalanche multiplication effects in semiconductors or superconducting nanowires that amplify the tiny energy deposits from individual photons into macroscopic electrical signals, enabling experiments that probe the foundations of quantum mechanics while supporting practical applications in quantum cryptography and precision metrology. The experimental capabilities now available include photon source engineering that creates individual light quanta on demand with precisely controlled timing, wavelength, and polarization characteristics, plus photon storage systems that can trap light pulses in atomic ensembles or optical cavities for retrieval at later times according to quantum protocols that preserve delicate superposition states. Perhaps most remarkably, quantum technology reveals that abstract theoretical concepts from early 20th century physics have become practical engineering tools that enable revolutionary capabilities from unhackable communication networks to quantum sensors that could detect dark matter or measure biological processes at the molecular level through photonic interactions. The philosophical implications extend beyond technological applications into fundamental questions about the nature of information and reality, suggesting that quantum properties represent more than mathematical abstractions, but rather essential features of physical existence that can be harnessed for computational and communicative purposes that transcend classical limitations. As we prepare to explore current research frontiers and future possibilities, remember that quantum technology demonstrates humanity's growing ability to manipulate the fundamental constituents of electromagnetic reality while revealing that photons represent far more than passive carriers of energy and information, but rather active participants in quantum processes that somehow bridge the gap between microscopic quantum mechanics and macroscopic technological applications. Tonight we stand at the frontier where cutting-edge research transforms the mysteries of quantum mechanics into practical technologies that could revolutionize human civilization, revealing how photons serve as messengers in a quantum internet that connects minds and machines through unbreakable cryptographic protocols based on the fundamental laws of physics themselves. Quantum cryptography exploits the fragile nature of quantum states to create communication systems where any attempt to intercept transmitted information automatically destroys the encoded data, providing security guarantees that depend on quantum mechanical principles rather than mathematical complexity that could potentially be overcome by future computational advances or algorithmic breakthroughs. Picture yourself sending secret messages through streams of individual photons whose quantum properties collapse irreversibly when observed by unauthorized recipients, creating communication channels where eavesdropping becomes physically impossible according to the uncertainty principle and measurement theory that govern all quantum mechanical interactions. Take a slow breath and contemplate this extraordinary achievement. Researchers have demonstrated quantum key distribution across hundreds of kilometers using satellite networks and optical fiber systems, establishing secure communication links that could protect sensitive information against any conceivable technological advancement, including quantum computers capable of breaking conventional encryption methods. The protocol exploits photon polarization states prepared in quantum superposition, where measurement in different bases reveals random bit sequences that can be used as cryptographic keys, provided both communicating parties can verify that no interception occurred during transmission through statistical tests that detect quantum state disturbances. Photon entanglement represents perhaps the most bewildering phenomenon in quantum mechanics, where separated light quanta maintain instantaneous correlations across arbitrary distances, despite Einstein's dismissal of such spooky action at a distance as impossible according to local realism and classical causality principles that assumed physical influences cannot propagate faster than light speed. Modern experiments routinely create entangled photon pairs through nonlinear optical processes where single high-energy photons split into correlated partners that share quantum properties in ways that cannot be explained through classical physics, enabling tests of Bell inequalities that consistently violate local hidden variable theories while confirming quantum mechanical predictions. These entangled systems enable quantum teleportation protocols where quantum states can be transferred from one location to another without physically moving the particles themselves, creating possibilities for distributed quantum computing networks where quantum information travels through photonic links to connect distant quantum processors into unified computational architectures. The technological applications of photon entanglement extend from quantum sensing systems that achieve precision beyond classical limits to quantum radar concepts that could detect stealth aircraft through quantum correlation techniques that remain immune to conventional countermeasures based on classical electromagnetic scattering principles. Ongoing mysteries surrounding quantum foundations continue challenging physicists despite nearly a century of experimental success, with fundamental questions about measurement, reality, and consciousness remaining unresolved while quantum technologies advance rapidly through engineering applications that sidestep philosophical complications about wave function, collapse, and observer effects. The measurement problem asks how quantum superposition states containing multiple contradictory possibilities somehow resolve into definite outcomes during detection events, with various interpretations proposing everything from parallel universes to consciousness-induced collapse mechanisms that connect quantum mechanics to metaphysical questions about the nature of existence itself. Quantum gravity research seeks to unify quantum mechanics with general relativity through theories that could reveal whether spacetime itself exhibits quantum properties at the smallest scales, with implications for understanding black hole thermodynamics, cosmological inflation, and the fundamental structure of reality that could transform our comprehension of photons, matter, and the cosmos. Recent advances in quantum foundations include tests of contextuality, non-locality, and retrocausality using photonic systems that probe the boundaries between quantum and classical behavior, while exploring whether future measurements can influence past quantum states through temporal correlations that challenge conventional notions of causality and time ordering. Perhaps most remarkably, current research reveals that photons serve as ideal probes for exploring the deepest mysteries of quantum reality, while simultaneously enabling practical technologies that could transform human civilization through quantum computing, quantum communication, and quantum sensing capabilities that exploit fundamental physical principles for revolutionary applications. As we prepare to explore future frontiers and ultimate questions about photon nature, remember that current research demonstrates how abstract quantum theories continue yielding practical benefits while deepening our appreciation for the profound mysteries that surround the nature of light, consciousness, and reality itself in ways that connect scientific discovery to the most fundamental questions about existence and our place in the quantum cosmos. Tonight, we peer into tomorrow's quantum landscape where photonic networks could reshape human civilization by connecting minds and machines through a global quantum internet that exploits the deepest mysteries of electromagnetic radiation to create technologies that transcend every limitation of classical physics and conventional engineering. Quantum networks represent the ultimate fusion of quantum mechanics and information technology, where entangled photons traveling through optical fibers and free space laser links could enable instantaneous coordination between quantum computers separated by continents, creating distributed processing architectures that harness the collective computational power of quantum devices worldwide. Picture yourself accessing quantum cloud computing services through photonic connections that maintain perfect quantum coherence across intercontinental distances, enabling calculations that would require classical computers longer than the age of the universe, while preserving the delicate superposition states that make quantum algorithms exponentially more powerful than conventional approaches. Take a slow breath and contemplate this extraordinary possibility. Quantum internet protocols could enable unhackable voting systems, ultra-precise global positioning networks, and distributed quantum sensing arrays that detect gravitational waves, dark matter interactions, and biological processes at previously unimaginable sensitivity levels through quantum correlation techniques that exploit photon entanglement. The technical challenges include maintaining quantum coherence during long-distance transmission, developing quantum repeaters that amplify photonic signals without destroying their quantum properties, and creating quantum memory systems that can store and retrieve photon states while preserving entanglement relationships across network topologies that span the globe. Fundamental questions about consciousness and measurement continue haunting quantum mechanics as researchers explore whether human observation plays a special role in wave function collapse, or whether any information gathering process suffices to transform quantum superposition into definite outcomes through mechanisms that could revolutionize our understanding of mind, reality, and the relationship between subjective experience and objective physics. These profound mysteries connect quantum mechanics to neuroscience through investigations of whether quantum processes in microtubules, ion channels, or neural networks could explain consciousness, free will, and the hard problem of subjective experience that has resisted explanation through classical approaches to brain function and cognitive science. Recent theoretical proposals suggest that quantum coherence in biological systems might enable enhanced efficiency in photosynthesis, avian navigation, and possibly even human cognitive processes, opening possibilities for biomimetic quantum technologies that exploit evolutionary solutions to decoherence problems while revealing deep connections between life and quantum mechanics. Technological horizons stretch beyond current imagination through quantum sensor networks that could map gravitational field fluctuations with precision sufficient to predict earthquakes, quantum simulators that model complex many-body systems for drug discovery and material science, and artificial intelligence systems that process information through photonic neural networks operating according to quantum mechanical principles. These emerging capabilities include quantum-enhanced medical imaging that could detect cancer cells through quantum correlation signatures, quantum communication with space missions that maintain secure contact across interplanetary distances, and quantum navigation systems that remain functional even when GPS signals are blocked or compromised through hostile interference. Perhaps most remarkably, future quantum technologies might reveal entirely new physical phenomena by enabling experiments that probe the boundaries between quantum mechanics and general relativity, potentially discovering whether space-time itself exhibits quantum properties at the Planck scale through measurements that could detect quantum fluctuations in gravitational fields using photonic interferometry. The philosophical implications cascade through every aspect of human understanding, suggesting that quantum technologies might eventually enable direct investigation of consciousness itself through quantum measurement theory applied to neural processes, potentially resolving age-old questions about the relationship between mind and matter through experimental approaches that remain inconceivable using classical physics. As we approach the culmination of our journey into photon mysteries, remember that future frontiers represent more than technological possibilities, but rather doorways into deeper understanding of reality itself, where photons serve as messengers carrying information about the fundamental structure of existence, while enabling human consciousness to explore its own quantum nature through technologies that somehow bridge the gap between subjective experience and objective physical law in ways that could transform our species into truly quantum beings. Tonight we reach the pinnacle of our exploration, where all mysteries converge into a unified understanding that transcends classical categories and reveals photons as entities so fundamentally different from ordinary experience that human language struggles to capture their true essence, while they somehow give rise to every electromagnetic phenomenon that shapes our reality. Beyond categories lies the profound recognition that photons neither fit into classical wave descriptions nor classical particle models, but instead represent quantum entities that obey rules so alien to everyday intuition that they challenge the very foundations of logic, causality, and existence while maintaining perfect mathematical consistency through quantum field theory formalism. Picture yourself witnessing these ethereal messengers as they dance between wave-like superposition and particle-like localization according to experimental context, revealing that reality itself operates according to principles that transcend the binary thinking that dominates human cognition and classical physics, approaches to understanding natural phenomena. Take a slow breath and contemplate this extraordinary synthesis. Photons embody pure quantum existence where properties remain undefined until measurement forces them into temporary classical manifestations, creating a universe where possibilities coexist until observation collapses infinite potential into singular actuality through mechanisms that connect consciousness to physical reality in ways that remain deeply mysterious. The quantum nature of photons eliminates the false dichotomy between waves and particles by revealing both descriptions as limited classical approximations to more fundamental quantum field dynamics that operate below the threshold of ordinary perception, while giving rise to all observable electromagnetic effects through statistical averaging over countless or numerous quantum events. Field excitations provide the deepest insight into photon nature by demonstrating that these massless messengers represent pure disturbances in the electromagnetic field that permeates all time, carrying energy and information at the cosmic speed limit without possessing substance in any conventional sense, while maintaining their essential role as fundamental constituents of reality itself. This field perspective transforms our understanding from photons as tiny objects moving through empty space to ripples in an invisible ocean that somehow gives rise to all matter, forces, and conscious observation through quantum processes that bridge the gap between abstract mathematical formalism and concrete physical experience. The electromagnetic field exists as a fundamental aspect of space-time geometry that manifests as photons when sufficiently excited, revealing deep connections between quantum mechanics, special relativity, and the mathematical structures that govern all physical interactions from subatomic scales to cosmic evolution across billions of years. The mediator role reveals photons as the fundamental force that shapes our electromagnetic universe through virtual exchanges that create every attractive and repulsive interaction between charged particles, from the bonds that hold atoms together to the radiation pressure that drives stellar winds and shapes galactic structures across cosmic distances. This electromagnetic mediation extends through every level of physical organization, enabling chemical bonding that creates complex molecules, neural signaling that generates consciousness, stellar fusion that produces heavy elements, and cosmic ray interactions that influence planetary atmospheres while maintaining perfect consistency with quantum field theory predictions. Perhaps most remarkably, photons serve as information carriers that connect all electromagnetic phenomena across space and time, enabling biological vision systems, radio communication networks, and astronomical observations that reveal the composition and evolution of distant stars, galaxies, and cosmic structures through spectroscopic analysis of electromagnetic radiation. The philosophical implications cascade through every aspect of human understanding, suggesting that photons represent more than physical entities but rather fundamental messengers that somehow bridge the gap between mathematical abstraction and physical reality, while enabling conscious beings to observe, understand, and manipulate the quantum foundations of existence itself. Modern physics reveals photons as perfect exemplars of quantum reality, where classical intuitions fail completely, yet mathematical descriptions achieve unprecedented precision in predicting electromagnetic behavior across all scales, from atomic transitions to cosmic microwave background radiation that carries information about the early universe across billions of light years. As we prepare for our final contemplation of photon mysteries and their ultimate meaning, remember that the synthesis reveals these massless messengers as far more than carriers of light and energy, but rather as fundamental aspects of reality itself that somehow give rise to matter, consciousness, and the mathematical beauty that enables human minds to comprehend their own quantum nature through scientific investigation that transcends ordinary experience while remaining grounded in experimental verification and theoretical consistency. Tonight we stand before the most profound philosophical revelations that photon research has unveiled, where the study of electromagnetic radiation shatters fundamental assumptions about existence itself and forces humanity to confront a universe far more mysterious and interconnected than classical physics ever dared to imagine. Reality's nature emerges through photon behavior as something radically alien to human intuition, where massless entities carrying energy and momentum challenge basic categories of substance and void, while demonstrating that our everyday experience represents a limited classical approximation to quantum processes that operate according to rules transcending ordinary logic and causality. Picture yourself contemplating the implications of wave-particle duality, quantum superposition, and measurement-dependent reality, recognizing that photons reveal a cosmos where properties exist in probabilistic limbo until observation forces them into definite states, suggesting that consciousness and physical reality maintain intimate connections that classical materialism cannot explain through purely mechanical processes. Take a slow breath and reflect on this extraordinary possibility. Photons demonstrate that the universe operates according to principles so foreign to classical thinking that human language lacks adequate concepts to describe quantum phenomena, forcing scientists to rely on mathematical formalism that somehow captures essential features of reality while remaining forever beyond complete intuitive comprehension. The philosophical challenge extends beyond physics into fundamental questions about knowledge, existence, and the relationship between mind and matter, as photon research reveals that scientific observation cannot be separated from the phenomena being studied without destroying the quantum properties that make electromagnetic radiation so mysteriously powerful and versatile. Observer effects represent perhaps the most unsettling discovery in modern physics, where the simple act of measurement transforms quantum superposition states into classical outcomes through mechanisms that remain deeply mysterious despite decades of experimental investigation and theoretical analysis by the world's most brilliant physicists and philosophers. This measurement problem suggests that consciousness or information-gathering processes play fundamental roles in determining physical reality, rather than merely revealing pre-existing properties, challenging materialist assumptions about objective existence, independent of observation, while opening doorways to radical new perspectives on the nature of mind and cosmos. Recent experiments with delayed-choice quantum erasers and quantum Cheshire cat phenomena demonstrate that photons can exhibit retroactive properties where future measurements determine past behavior, violating classical notions of temporal causality, while suggesting that information and consciousness might operate according to non-local principles that transcend spatial and temporal boundaries. Information carriers reveal photons as potentially more fundamental than matter itself, embodying pure information that somehow gives rise to all electromagnetic phenomena, from atomic bonding to cosmic evolution, through quantum processes that bridge abstract mathematical structures with concrete physical manifestations across all scales of space and time. This informational perspective suggests that photons represent the universe's method of maintaining consistency and connectivity across vast cosmic distances, enabling correlation and communication between separated regions through quantum entanglement effects that operate faster than light while somehow preserving relativistic causality through mechanisms that remain theoretically puzzling. The philosophical implications extend into questions about whether information represents the most fundamental aspect of reality, with photons serving as messengers that carry not just energy and momentum, but the mathematical relationships that determine atomic structure, chemical bonding, biological processes, and conscious experience through electromagnetic interactions. Perhaps most remarkably, photon research reveals that human consciousness participates actively in cosmic evolution through scientific observation that somehow connects subjective experience to objective physical processes, suggesting that mind and matter represent different aspects of unified informational reality, rather than separate substances interacting through mysterious mechanisms. Modern physics hints that photons might represent pure mathematical structures made manifest, embodying geometric relationships and symmetry principles that somehow give rise to all physical phenomena while maintaining their abstract character as solution to differential equations that describe electromagnetic field dynamics throughout spacetime. As we approach our final contemplation of photon mysteries, remember that philosophical implications extend far beyond academic speculation into practical questions about consciousness, free will, and humanity's role in a quantum universe where observation and reality remain mysteriously interconnected through electromagnetic processes that somehow bridge the gap between mathematical abstraction and physical existence while enabling conscious beings to contemplate their own quantum nature through scientific investigation. Tonight we reach the end of our cosmic journey, where all questions converge into a single profound realization that transforms our entire approach to understanding light, revealing that the very act of asking what exists inside a photon betrays classical assumptions about substance and emptiness that quantum mechanics has rendered obsolete through decades of experimental revelation and theoretical breakthrough. The wrong question emerges from our deeply ingrained habit of thinking about particles as tiny containers holding mysterious contents, when photons represent something far more radical and beautiful. They are not objects with interiors, but rather the dynamic manifestation of electromagnetic field activity itself, the very substance of space-time curvature and quantum fluctuation made temporarily observable through measurement processes. Picture yourself releasing the need to find hidden mechanisms or secret compartments within light quanta, instead embracing the revolutionary insight that photons represent pure process rather than static entities, embodying the fundamental activity of reality itself as it weaves energy, information, and consciousness into the cosmic tapestry that enables stars to shine and minds to contemplate their own existence. Take a slow breath and contemplate this ultimate truth. Photons are not separate from electromagnetic fields, but rather represent what fields become when they reach sufficient excitation to manifest as detectable quanta, revealing that asking what lies inside light is like asking what exists within the concept of motion itself, or what fills the interior of mathematical relationships. This paradigm shift eliminates the classical subject-object distinction by demonstrating that photons embody the very activity through which spacetime communicates with itself across cosmic distances, creating correlations and connections that somehow give rise to stable matter configurations while maintaining their essentially processual character as pure electromagnetic becoming. Our connection to the cosmos through photon interactions extends far beyond mere sensory experience into fundamental participation in quantum processes that connect every conscious observer to distant stellar furnaces, ancient supernovae, and cosmic background radiation that carries information about the earliest moments of universal evolution across billions of years and countless galaxies. Every photon reaching your retina represents a direct physical link to its source that transcends spatial separation through electromagnetic field continuity, creating intimate connections between your consciousness and distant astronomical phenomena through quantum processes that operate according to principles far more mysterious and beautiful than classical physics ever imagined. These photonic messengers carry not just energy, but information about atomic composition, temperature, magnetic field strength, and evolutionary processes occurring in stellar atmospheres, interstellar clouds, and galactic nuclei, while somehow maintaining perfect fidelity across cosmic distances through mechanisms that preserve quantum coherence despite countless intervening interactions. The final mystery reveals that studying photons ultimately means studying consciousness, studying itself through electromagnetic interactions that somehow bridge subjective experience with objective physical processes, creating a reflexive loop where mind investigates matter only to discover that both represent different aspects of quantum field dynamics operating throughout spacetime. This profound circularity suggests that photon research represents humanity's deepest attempt to understand its own quantum nature through scientific investigation that somehow transcends the classical separation between observer and observed while revealing fundamental unity underlying apparent diversity in cosmic phenomena from subatomic to galactic scales. Light reveals the quantum nature of existence itself by demonstrating that reality operates according to principles that transcend classical categories of wave and particle, substance and void, mind and matter, while maintaining mathematical consistency through field equations that somehow encode the deepest secrets of cosmic evolution and conscious experience. Perhaps most remarkably, our journey into photon mysteries demonstrates that scientific understanding represents a form of cosmic self-awareness where the universe investigates its own electromagnetic nature through conscious beings who somehow emerge from quantum processes they now study, creating an extraordinary feedback loop between physical reality and conscious observation that remains among the deepest unsolved mysteries in all of science and philosophy. As we close our exploration of light's ultimate secrets, remember that photons represent far more than particles or waves, but rather fundamental messengers that connect every aspect of cosmic evolution while enabling consciousness to contemplate its own quantum foundations through scientific investigation that bridges the gap between mathematical abstraction and lived experience while revealing that light itself represents the very fabric from which reality weaves itself into existence. Tonight, we close our extraordinary journey through the quantum realm, where photons have revealed their deepest secrets and challenged everything we thought we knew about reality itself. If this gentle exploration into the heart of electromagnetic mystery has brought you wonder, peace, or new understanding about the universe we inhabit together, Your quiet like and soft subscription create a constellation of support that enables these contemplative science stories to continue reaching gentle hearts like yours. Perhaps you'd share in the comments where you're listening from tonight and which aspect of photon nature surprised you most, whether it was their massless momentum, their virtual particle exchanges, or their role as pure field excitations that somehow give rise to all electromagnetic phenomena throughout the cosmos. Your words, your presence, even your silence become part of this shared exploration, where consciousness contemplates its own quantum foundations through the very photons that enable vision, thought, and the mysterious connection between mind and light that makes scientific understanding possible. Until we drift together again into another cosmic mystery, remember that every photon reaching your eyes carries ancient starlight and quantum secrets across impossible distances to illuminate the wonder that surrounds us always.